Have you ever wondered what happens when you click on a YouTube video? So within a second, the video starts playing. It feels like simple, but behind that single click, thousands of servers and software services work together to make it happen. The same thing happens when you send messages on WhatsApp, order something on Amazon, watch Netflix or scroll through Instagram. Let's take YouTube as an example. So what happens when you click a video? So your request travels through YouTube servers, go through the servers. The server fetches the video details, load comments, update the view count, record your watch history, and find your nearest server to stream that particular video quickly. So while you are watching, more requests keep running in the background to load recommendations, adjust video quality, and buffer the next part of the video. And all these things happen in just a fraction of seconds. Now imagine millions of people doing this at the same time. How do companies make sure their applications stay fast, playable, and never go down? This is exactly what system design is all about. So you need to know system design if you want to grow your skills or upskill you by yourself. In this video, we will learn how large-scale applications like YouTube, WhatsApp, Amazon, Netflix, and Instagram are built, and understand the technologies and architecture and the power behind them, and how that systems are working. All this stuff will be explained in this video. Stay tuned up to the end so that you can get to know all information. In this video, I will also going to explain you the complete AWS workflow, AWS services. I'm going to explain around you 15 to 20 services so that you can understand each and every service practically also as well. So I hope you will get some insights from this video. So let's get started. So first of all, we need to start with the definition of the system design. So system design is the process of defining the architecture, components, modules, interfaces, and data flow of a software system to meet specific business. See here, business is very important, and the functional requirements is also very important. So let's say we have a company called X. This company build some product. Let's say the product is Y. So this product that they need to make sure that its system design is very perfect, good. Why? Because if this product has to be scaled, then they need a perfect and good system design for the scalability. And if they want to upscale and they want to add more features, then also they need this system design plans before building this. So, and also it is a structural blueprint like a building architecture. It ensures a system scalable, reliable, and performant as it grows. So in the system design, we have two things. First one is HLD and second one is LLD. So HLD, the full form of HLD is high level design, and the full form of LLD is low level design. So here you can see the table difference between HLD and LLD. So HLD is the overall picture, the main picture or the overall picture. First of all, the engineers or the designers will plan the HLD, the high level design. In this high level design, we need to talk about the overall structure, overall project, overall the software that we are going to build. That has overall architecture, a big picture of the software, and what are the components that we are going to have, and what are the services that we are going to build, and how we are going to do communication between the services, the data flow layer, that's how we can scalable, and what is the database that we are going to use, and which API services that we are going to use, and all the infrastructure planning and all the stuff will be happened in this high level design. Whereas if you consider the low level design, so we have internal implementations, small details like writing a small code, writing a small function and all the stuff, and writing a classes, objects, methods, algorithms, actual pure business logic code structure, database schemas, API endpoints and responses, and source code design. All this stuff actually like real coders will all be involved in this low level design, and all the designers and all the Figma and all the stuff will be done in this high level design. So I hope you got this, what is the difference between high level design and low level design. Now quickly, if you come here, so first of all, we need to understand some of the questions that we need to answer, or we need to understand why we need to bother about the system design. So first of all, let's say if you have some questions like how do we handle millions of users, right? If you want to handle millions of users, let's say if you build a system that's for 100 users, let's say suddenly 500 users came, no problem. 1000 users came, no problem. Let's say 1 million users came, then your site definitely will crashes. Then that time this point will definitely raised. The next point is where should we store the data? It's very important. Whether you store in your private servers, or if you take the like a rented system, or you can buy a server on the cloud, anything. So this also matters. Next, how can we make the system faster? How can we make system faster, which is nothing but the latency. How can you make the latency low, so that when you click the button, then instantaneously the user has to get all the information. So nowadays the time is very important here. Why? Because in my case only, if I go to some website, if the website loads faster, I will in that website. If that website loads slower or I did not get the data, so I will simply go back out of the data of that website. So that happens to everyone in the world. So here faster is very important. So you need to make your laptop or your company faster. So that's why this point is very important. And the next question is, what happens if a service crashes, very important. Let's say that the services like Amazon, Flipkart, they will never crash, because those are very well system designed very well. So that's why they will never crash. So that's the reason you will need to design your software as such it will never crash. And the next important question arises is, how do we companies avoid downtime? Okay, sometimes the companies can have downtime, but not throughout the year, throughout the month, throughout the day. It should not be happen like that. So some downtimes can be there, but not all the times it should not be downtime. The next point is, how do we scale globally? Next big thing is, in your country you have developed a good product, and now you want to scale globally. Then these all points can be simply answered with the help of the system design. So with the help of the system design, you can simply scale, answer all these questions. Now we need to understand a bit of the system design. If you see clearly over here, in the system design we have all these points, like at a scale reliable, if you consider system design. So low latency and high throughput. So don't worry, I will explain what is meant by latency and what is meant by throughput. And efficiency also important. And system design talks about the infrastructure of the software, and it has some components. Okay, now the main thing that we need to talk about in the system design is all these stuff, which is as you can see here. First one is scalability. As you know, once the software has been built, it has to be scaled if your users are growing. The first point is scalability. Availability, high availability, you should be high available. Reliability, performance, security, fault tolerance, maintainability, cost efficiency. All these points has to be maintained with the help of the system design. So in the system design, all these topics will be talked about, and you need to take care of all these topics. So as you can see clearly over here, in the HLD versus LLD, so it's not versus, I can say it's about both are first. HLD is decided, then only LLD will be decided. Why? Because the HLD is the high level design. The first it will be discussed by the developers or the designers. It will be both will be negotiated about the software or the product. Then only low level design or the software coders, actual coders will code the product. So developers, the time, see if you see, this is the actual timeline. So the timeline for developer starts way before coding here. So the first business requirements will be discussed in like all the specifications they will discuss. Next SRS, like system requirement specifications. Next HLD will come. Next low level design will come. Next actually they will code. This low level designers will code that. Next here comes the actual coding. Then after this code is completely fine, then they will test the code with the help of the unit testing. Then they will test with the component testing. Then they will start the system integrating testing. Then system testing, and finally acceptance testing. So this is QA engineering. The testers start with the code and they move up to the business requirements. This is meant by that. This all parts will be done by testers, and these two parts will be done by both designers and as well as the coders as well. Now if you see the main differences, I have already listed here. The architecture, component, services and communication is a big picture. What is the HLD? And in the low level design, focus on classes, objects, APIs, database schemas, design patterns and implementation designs. So if you also want to know more about that, the difference and all the stuff, so you can pause the video and you can take the screenshot of this. So this is the difference between high level design and low level design, the difference table. So as we already discussed, what happens when you click a YouTube video. So we have know that when you click the YouTube video, what happens. So now we will understand what are all the stuff happens in the behind the picture. So first of all, when user clicks the button in the internet server, like it will go through the internet, and it will ask the DNS server, and it will go to the load balancer. Then it will ask the YouTube API gateway that where can I get that. Then it will check for the authentication server. So basically in the YouTube and Google and all the stuff will be used with the OAuth service. I will also discuss what is meant by this OAuth service. It's nothing but whenever you go to any website, you see something known as sign up with Google, sign up with Facebook, that right. So that is known as OAuth. So the OAuth service will be there. Then video matching metadata services. then it will be going to query the database, and finally recommendation service will be provided to us. Then common services will be available. Then CDN, nearest CDN is nothing but content delivery network. Then finally video will be streamed to our clicked when we click right, so that video will be streamed to us. So finally it will also show you analytics and logging to the users. Okay, this and all the stuff will be happening when you click when you click a YouTube video. So not only this, there are so many things I have highlighted. So it's a simple overview on the top, but there are so many things running behind the scene. So in general, we use for the front end, we use React, Angular, Vue, these kind of popular frameworks. For the back end, we use the Node.js, Spring Boot and Django for the back end. And for the load balance, we use Nginx, HA Proxy and AWS ALB. And for the API gateways, we use Kong, AWS API Gateway. So databases, MySQL and Postgres. So for the caches, we use mainly Redis. So content delivery network, CDN. So Cloudflare, Akamai, Amazon CloudFront. So for the object storage, we have Amazon S3. So message queue, we have Kafka, RabbitMQ. Monitoring, we have Prometheus and Grafana. And logging for we have ELK stack. So these are the popular frameworks for the full stack application or the complete software that now if you come back. So first of in this video we are going to discuss section by section. So the first section that we are going to discuss is about scalability. So in the scalability that we need to understand is, so in the scalability we have two types of scaling. One is vertical scaling, another is at horizontal scaling. So what is meant by vertical scaling and what is meant by horizontal scaling? So if it grows vertically, let's say if it grows vertically, this is vertical scaling. So what is meant by scaling vertically in this way? So let's say this is your system which has less resources, let's say 8 GB, a simple example I am saying, then you scale up to 16 GB, then you scale up to 32 GB, then you scale up to 64 GB. So a scale up means what? You already had 8 GB, another you spend money to acquire another 8 GB to get it as 16 GB, then another 16 GB you spend to get that on 32 GB on the same mission. So like that, if you are increasing, then that is known as vertical scaling. Then we have the horizontal scaling. So this is one system. So if you want to increase more resources, then you can add more systems or more. This is one server, server 2, server 3 and all the stuff. So this is known as horizontal because you are scaling horizontally. So scale, you can also say this is known as scale out, and this is known as scale up, this is known as scale out. So add more servers needs load balancer plus stateless services. I hope you got this. If you not understood even more, so you can see the picture clearly over here. So here we are depicting the vertical scaling, and here also we are depicting the horizontal scaling. So vertical scaling is nothing but increasing the power, the processing power. So you can see that for the one mission only you are increasing the power. So horizontal scaling is nothing but you are increasing more and more missions. Here without this one mission you are having multiple missions, so that all combinedly can do same work at a time. So if you see more examples, so if you clearly observe this table, so I want to talk more about this table. So in the AWS services, we have some of the services which is direct horizontal scaling. Horizontal scaling is nothing but this way. So vertical scaling is nothing but this way. So use cases, what is the use case of this AWS EC2? So what is meant by EC2 and all the stuff? What is this EC2? Here this image also depicts the same. So this is the vertical scaling and this is the horizontal scaling. Now if you consider what is meant by the EC2 is nothing but elastic computer, or the majority of the AWS services they will name it as or EC elastic container, elastic, this kind of naming conventions they have. So elastic is nothing but elastic is nothing but whatever the thing that you are using, that only that you need to pay. So that's why it is elastic. So first of all the payment is zero. So as your increase is going on increasing, so that's why according to that you need to pay your prices. So if you see the Amazon AWS services, some of the services, so we have Amazon AWS EC2 instance. So we have direct horizontal servicing, and we have vertical service, and what is the use case for this, and we have elastic load balancer. I will explain what is meant by load balancer. And we have Amazon RDS, it is a relational database. So we have AWS auto scaling ECS, okay, and we have Lambda services, DynamoDB and SQS Q service. So in this video only we will understand what is meant by Amazon SQS Q service, okay. and we need to know what is meant by lambda services also. So if you go further, up to now we have understood what is meant by scaling, okay, what is meant by horizontal scaling and what is meant by vertical scaling. Now we need to understand what is the, like in the section 2 we need to understand, it's a very important point, what is meant by latency and throughput. So up to now I have discussed so many times and I have mentioned that throughput and latency. So what are these throughput and latencies? So the latency and throughput is nothing but, the first word is latency. Latency is nothing but time for one request. So the time, it is the time, latency is the time. And what is throughput? Throughput is the request handled per second. Let's say per second you can handle 10 requests, okay, or 10 per second. What are the 10 per second? That's a request, okay. So our goal is to low latency plus high throughput. Why? Because we need low time. Within the low time only we need to get all the output, and we want high throughput because we have more number of requests, large number of requests we need to send in the less number of time. So this is our high prioritized thing that we need to make in every software, okay. So that's the thing in the system, good system design, we need to make sure these two are there at the proper conditions. And one more thing, so one vice versa. If you want high latency, then you need to sacrifice high throughput. If you want high throughput, you need to sacrifice low latency. So if you want both of these stuff, you need to have high servers, high end servers, and more big computing missions. And if you see, the same thing is depicted with the help of this diagram also. So in the upper diagram you can see the time needed for the packet transfer. So here is the internet and here is our browser or the services. So this data is coming from here, this side, and here you can see, here we are talking about time. In the latency, in the throughput, we are talking about the large number of data, the quantity of data. And here also it is saying that normal network and difference with the high latency network. So high latency means high time that we don't want. So always remember, the latency should not be high, it should be low. And the next section that we are going to discuss is in the section 3, is about availability versus consistency. So this is also very important, that always that we need that is called as CAP. So CAP. So what is this meant by CAP? We'll get to know in a while. So C means consistency, A means availability, and what is meant by this P. So we will see that. So first of all, let me read out these statements for you. So in a distributed system doing a network partition, you must choose the consistency and availability. So CP, systems MongoDB default, HBase favor correctness. So AP systems Cassandra DynamoDB favors uptime. So CA, only possible without partition, rare in distributed systems. So here A is nothing but the availability, P is nothing but partition, A is nothing but consistency. That if you want to know more about that, you can see about this diagram clearly. We have CAP theorem. What is this CAP theorem? So here C is consistency, P is partition tolerance, and A is availability. So always there is a triangle type of thing in there, he is there in between them. Okay, so you can read more about this consistency. So every read receives the most recent write or an error. So then the partition tolerance, we have the system continues to operate despite an arbitrary number of messages being dropped or delayed by the network between. So in the availability, we can read out this statement that every request receives a non-error response without the guarantee that it contains more recent write. So you can pause the screen and you can read more about this CAP theorem, and we have the difference between consistency and availability over here. So in the consistency, we ensure all the nodes have same data. Consistency is having same data. Availability ensures every request receives the same response. Let's say you make 10 responses are same. In the 10 responses, you need to get the same data rather than that data has been modified. So if you modified the data by yourself, that's another matter. But if you don't modify, you need to receive the same data. That is known as availability. By 24/7, you need to be available to the user. And may delay response to ensure data up to date. Always provide a response even if the data is stale. Stale is nothing but the data is modified or corrupted, or it is known as dirty data. So in the banking systems, transactions and all the stuff, we need to make sure the data is consistent. And web service and online applications, we need to make sure that we are available 24/7. So high complexity due to synchronization, because consistency is the thing that you need to make sure very important, because the same data will be there for all throughout the day. So it's somewhat consistency is very important. And availability, low complexity, easier to implement, because you can be available 24/7, because we have so many things, like we have EC2, which is a computer running on our cloud, and we have VPS. Example of VPS is a hosting. So you can take a hosting or VPS cloud services, and you can run all the services there. It will be up and running 24/7. So you need not to, you can be highly available, but it is difficult to maintain your app consistent. Okay, so this is the Cape theorem. And in the Cape theorem, someone calling that as CP, ACA, AP. So what are these CP and all this stuff? So if you see clearly, so if you draw a like a pie, it's not pie chart, I can say it's a collision diagram. You can see Venn diagram. I can say it's a Venn diagram. V and NA, so sorry for the bad handwriting. So you can see CP, CA, AP, all the three where it has been combined. So CP is nothing but system guarantees the consistency and partition tolerance. So CP is nothing but two of them are satisfied, and the third one is we need to be a little bit compromised. So in the CA also we have the consistency. See, you can see it provides strong consistency and availability, but we may not be guaranteed about partially tolerance, and we have something known as CAP. So AP, the system can be distributed and high promise to be highly available. Okay, so this is when, with the help of this Venn diagram, we can understand all these three terminologies, and we have something known as Cape theorem. You can see with the help of this diagram you can understand. So also known as Brew's theorem, a principle in distributed systems that state that it is the impossible for a distributed system to simultaneously provide all the three of the following guarantees. So consistency, availability, and partition tolerance. So it's very important to make sure all these three are available, but unfortunately you can only provide two. If you want to provide three, you need to have so much resources, so many servers and all the stuff running for you. So you can see CA means consistently available, AP means available partition, CP means consistent partition tolerance. You can see all the diagram depicting that the same thing over here. And the next thing that we need to understand is acid versus base. So acid is nothing but it's not a real word acid. It's nothing but SQL. Okay, atomicity, it has some full form or something like that. You can see, you can understand. So A is nothing but here atomicity, C is nothing but consistency, I is isolation, and D is for durability. So all these four things has to be there for a perfect well software system. So strict used in banking or DERS. So base is nothing but it's not a real world base. It's not a thing that is represented for the NoSQL. So here B is nothing but basically available, software state, eventually consistent. So it's used for high scale feed analytics. So you can see these are the SQL services we have. We have from the Oracle, PHP, MySQL, and we have Microsoft like SQL Server. And what is NoSQL? We have like MongoDB. So MongoDB is one of the NoSQL databases. In there we have document DB, key value pairs, white column store, graph store. So all this stuff will be in the NoSQL kind of stuff. So the next section that we need to understand is the section 4. This is also a very important part of this system design. So the next part is about networking. So the networking also very important if you want to communicate between two systems, or if you want to get the data from the main server. So if you click a button on your website, then how the actual flow happens. So you can see how DNS resolution happens. So basically your browsers will go to the OS cache. OS means operating system cache. In our operating system, is there any before cache or not? It will check that first. If there is cache, it will use that. Otherwise it will go to the resolver. After resolver, it will go to the root DNS server. Then it will call the TLD, then authorization server, then IP address will be returned to the final user that he is requesting. So you can see the same thing is depicting with the help of this diagram also. The user actually when clicked this client or the browser, so first of all he is requesting like for a record. So this local DNS resolver, what it will do, it will be going to go to, so first of all let's say user is requesting for any .io domain. So it will ask go at .io he is asking for. So here it will be going to go to the root name server. So in the root name server it will check in the top level domain server also. So what is the top level domain server? This will be basically filtering that .io domain. So it will be going to check go to register, that kind of stuff. And finally it will be going to check in the second level domain, and finally this IP address will be returned to this local DNS resolver. So and finally this IP address will be returned to this client, and in this client this IP address will be pointed to that particular address. So you can also see what is that hierarchy of the DNS server. So clear hierarchy of the DNS server. We have first of all we have root DNS server. So from the root DNS server we are having the TLD like DNS top level. TLD here you need to understand what is meant by TLD. TLD is nothing but top level domain. So it's a very simple full form, that is top level domain. So top level domain is nothing but all the dot let's say we have something like .com, .net, .dev. So these and all the things are coming under the top level domains. So we have something known as TLD, top level domain DNS servers. So after that, let's say someone is calling for the example.com. Then in this .com top level domain, it will be going to check for the authoritative, and it will be going to return to that particular services. So in this way, these networking basics are there, or the things happens. And the next important thing is the load balancers. So what are these load balancers? So load balancers, so first of all we need to understand, let's say this is the user browser and this is the services. So if you asking here directly, it's no problem because we have only one server. So let's say I will call it as server 1. So this is user 1. So let's say here we have another server, so here you have another user. So here it will ask for this, so that's no problem. So let's say there are 3 servers, then how it is possible? So we have only 2 users and we have 3 services. Let's say this has been crashed, but it will be automatically going to hit this only. He will not get any back response. So that is the reason that we are always going to use these third server also as well. So for that purpose, we need to have in between here the load balancer. So in between we are going to have a load balancer. So what is this load balancer will do? The first of all, it will take all the incoming responses and it will be going to divert to the server. It will be calling as load balancer. So it will be going to redirect all the requests to whatever the servers that are running, and it will be going to distribute, let's say, another server also there, and that also will be if the server also down, it will be going to automatically going to redirect to this server. Okay, so this is the flow how the load balancer works. So there are 4 types of load balancer we have. That is, first one is L4, the next one is L7, and the next one is algorithm. So in the L4 we call it as transportation layer. So routes based on IP port, fast, less intelligent. So in the application layer we have routes based on the URL headers, cookies, matters. Okay, in algorithms we have round robin, least connections, IP hash, and weighted round robin. So this is the overall picture of the how load balancer works. In between a box, a black box that will be going to redirect or reroute your request to multiple servers. So this is the load balancer. So if you want to understand or simply depict with the help of picture, so you can see the pictures. So here we have so many clients that is requesting to the internet. So this all will be going to go to the internet. So after going to the internet, we are going to go to the load balancer. So in the load, this is the main part. In the load balancer, we'll be going to separately ask for the every server. Are you up or not? If that is up, it will be going to redirect all the requests to that. Okay, and it will be going to the name itself suggests it will be going to balance. It will be going to balance the load. So there are 2 types of load balancers. The first one is the sticky, not 2 types. The first kind of requesting is without sticky session, and the next one is with the sticky session. So what is meant by this sticky session and non-sticky session? So basically this sticky session is nothing but the normal session that we are going to use in our day-to-day life. If any system is really big, really in a scalable manner, that is using load balancers, that is known as without sticky session, because we have load balancer in between. And if that is not a sticky, means you are going to send, if you are sending cookies with your request, that is known as a sticky session. So if you understand what is meant by a sticky session in detail, so you can see the image here clearly. So actually we have total here 3 servers, you can see clearly, server 1, server 2, server 3, and we have user browser over here and a load balancer in between. So initially the user will be going to request the load balancer, and load balancer will be going to go to the first request, okay, or the first server I can say. So in the first server it will be going to create a session for us. So that session will be creating and it will be going to send back to the load balancer. You can see we are getting back a cookie here, and this cookie will be stored in this load balancer. You can see store server mapping. So after that this cookie will be with the modified response will be sent it to the user browser. So after that, whenever user wants any data back, then he can ask with the another request. So you can see here it is we have request to with the cookie. So further all requests will be handled with this cookie only, and this is only in the first server. See, and always it will be going to send with to this as first server. Why? Here we are getting cookie with the first server, so that's why we are only going to the first server. And again response coming to here, and third request, so always go to the first server and you are getting response back here, and finally response back to the browser. So in this way you're only the user browser is always talking with the first server rather than talking with the second server and third server. So these 2 servers are always idle. So in this situation, this is known as the non-sticky. So non-sticky is basically handled with the cookies. So Okay, this is the basically handled with the cookies. So in the general way, we are not going to use this. We are going to use the load balancer. So load balancer will be routing multiple requests to the multiple servers. So this is one of the good way of the better system design. So you can see clear difference. What is the difference between the sticky session and the load balancing? So in the sticky session, we facilitate or consists user servers interactions. So in the load balancing, we performs equal scattering of network traffic. So effective when data is stored in the server's memory. Augmented server performance promotes dependency and accessibilities. So mismanagement might result in disappointment server load. So misconfiguration may cause session interrupts if not paired with the sticky sessions. So you can see a clear session or a clear difference between sticky and load balancing. So up to now, I hope you got this what is meant by load balancing and all the stuff. This load balancing is one of the important part of the system design. If you want to make a better system, you need to have a better load balancer kind of stuff. So now I want to show complete details about the AWS so that you can understand practically also. So basically you can come to your any favorite browser. In the browser, what you can do is you can type the AWS console like that. You can see. So this console, the first website is the official website. You can go to the Amazon Web Services. So basically this is the cloud services platform. In this you can take complete servers on the cloud, and you can run Ubuntu on it, or you can do whatever, or you can host your website. You can do whatever you want. And not only that, you can have your load balancers, all the stuff. Quickly create an account. It will ask your credit card details, and you can give for practicing. It's a basic free sessions only. So if you have this already have an account, you can simply click on the sign in with your Google account or something like that. So you can see if you already have an account, it will going to ask you don't have. So if you want to sign up as a root, you can click on the sign in as a root user. So basically it will be going to again come to this here. You can see it is asking email for me. So as I can see, I will enter my email and I will click on next, and it will be going to ask password. You can simply enter your password and you can simply click on sign in now. And basically from your mobile you need to going to scan this. Okay, so Microsoft Authenticator and that kind of authenticator you need to open in your mobile. So basically from this app you need to scan this QR code so that you can get access to this. So once your scanning is done, it will be going to automatically it will be going to say the device has been successfully connected to your Microsoft Authenticator. So you can see this is the console of the AWS. So basically if you visited any recently services, you can see. So if you got any recent services, you can see all the services. So after signing and up all the stuff, you can, if you want any sign up video, you can see on the YouTube, you will get that. Your first time after signing up, your dashboard might not be same as like this. Okay, but I will explain what are the stuff all is there one by one, so don't need to worry. So you can see, the first of all, if you want to see your account, you can see click on this, and you can see how many remaining credits that I have left in my account. You can see clearly over here. So after seeing that, if you want to see more about details, you can go to the account name and account name ID and all the stuff. You can see clearly over here. If you want to sign up, you can simply sign out from here. And as I am using the free tier of this Amazon AWS, so you can see how many days left I have left. You can also see that here, and you can see that that I am running all the stuff in the free plan status. Okay, then I am basically here the regions. So local regions and regions is very important part. Here each region states it's in the different states and different countries, and it's actually a physical servers. You heard me right. It's actually a physical real server in that country or in that state. If you suppose going from Mumbai to Seoul, so it's actually going to ping, or it will be going to all the requests, and all your data will be physically stored in this server in the Seoul in the north. So in this fashion, so always make sure what is the region nearest to you, you select that region only. So currently I'm in India, so that I am selecting Mumbai because I will get the low latency. That's why I'm selecting Mumbai. Okay, so after selecting your particular region, you can see all the notifications, all the settings you can set over here. And not only that, so let's say some of these, all the services that I want to explain clearly now. You can see it is saying welcome to AWS. Okay, you can see all the stuff. You can modify this dashboard according to a requirement. But before that, I want to explain all these services one by one. So the first and foremost important services in the AWS is, first one is EC2. So if you click on this EC2, so what is this EC2? So EC2 is nothing but Elastic, like Amazon Elastic Compute Cloud 2. So basically if you want to own a computer, or if you want to have your own computer, own laptop which runs 24/7 in cloud, then you need to definitely check out this AWS EC2. So how you can launch this AWS EC2, or how you can get the server access and all the stuff. So you need not to do anything. You can simply click on this launch instance. So after that, you can see getting started walkthrough. You can click on this get started. So after you came here, you can see all the stuff that you can do here. Basically, you can select whatever the operating system that you want to install in that particular server or in the particular laptop. Laptop is nothing but it's a particular server, right? So let's say you want to download the Ubuntu, and let's say if you can give a name, let's say I will name it as a test. So example, that's your ways, right? That server name that you are going to have here. So after that, we have Ubuntu here, and if you want to choose any of the like more image, so you can see these are all the Ubuntu images that you have, but I'm going to go with this free tier only. It's for demo purpose, it's okay for me. You can click on this. Now you can simply come over here. You can see the basically you can see instance type. So what is meant by this instance type? So instance type is nothing but the type of mission that you are taking. Okay. So if you simply expand this, so I have got the T3.micro. It is eligible for that free tier, eligible because it's worthwhile. Then after you have this also for the free tier. But make sure remember one thing, that also your credits will be gone faster. Why? Because if you select the more bigger mission, that will be going to cost you, and this cost will be cut down in your free resources. Okay, the account is free. You can please go through any YouTube video and you can make your free account, and you can use and you can follow according to me. Okay, so this T3.micro have this 2 CPU and 1 GB of memory, and this T3.small you have 2 CPU and 2 GB, and if you go on so on, the list will be going on like this. And if you want these big missions, you need to pay for them. It's not eligible for the free tier. Okay, so I am perfectly alright with this because it's for a demo purpose. So I will simply collapse that, and if I come here, so if you want to connect with your terminal itself, you want to connect with the CMD, you can simply generate a key value pair. But for now, I am not going to generate this key value pair, and you can also give all these networking settings and all the stuff. So you can also select existing group, or you can allow any from any IP address, and if you simply come down, that's it. So you can simply click launch instance button over here. So basically it will be going to ask you something. So finally you can again click on this launch instance. So basically now it will be going to make it is asking a key pair name is required. So you can let's say test. So it's saying it's mandatory. So I am saying that test. So I am saying it as proceed without key pair. So you can your wish. So you can create a new key value pair if you want to do SSH to your laptop, or you can proceed without any key value pair. So you can simply click on this launch instance. So if you click on that launch instance, it will be going to actually create your server, create your laptop, means your computer on the cloud. So basically our computer on the cloud has been successfully created. Now you can close here. So you can see the dashboard. If you click on here, you can see complete dashboard of the AWS or EC2. So I will explain all the services, don't worry. So you can see, you view all instances. You can see, you can click on here. So you can see the running instance will be seen over here. So you will be not charged without using that resources, because if you come back again, if you click here again, or if you click on these instances, you will be going to see this instance. So unless this instance is running, you will be charged from your account. You will be detected from the end of this month. Don't worry, you will not be automatically charged. First of all, you will get a mail. After that only you will charge. So you will be for a demo purpose, after making this instance, you please delete it. So I will also show how to delete this. Don't worry, because it's very important to delete. As not a regular user, you need to delete this instance. We are understanding load balancers, right? So this is the particular server. If you want to go through this particular server, you can simply click on this instance ID. So this is the particular instance, or this is particular laptop. So this is the IP address of the laptop. You can copy this and you can point out to this any of the domain that you want, like example.com, charan.com, that your particular favorite thing.com. So if you can also go to this particular IP address. You can see now currently there is nothing running over here, so that's why it's loading. So again I came here back. So this is the instance ID, and you can see the host name and all the stuff showing over here. Now if you if you want to go to inside of this container, so you can see a little button over here. It's saying that connect. So before that, you can come here. You can see site is can't be reached, because that nothing is running in this thing. We just bought the services. We just got the IP address of the computer. We just did nothing in that. So you can simply see a button called connect. So you can simply click on this. So you can come here. You can simply click on this connect button. So in your local laptop only you are going to go, you will going to get a terminal. So this is the basically Ubuntu terminal. So you can see this is the Ubuntu terminal. You can simply clear the terminal. So if you click on this ls, you will be not going to see any of the stuff. If you see cd dot dot, so you will be in the home directory. Now if you want to see all the things that you have, so we have only one thing called Ubuntu. So this is the main default user we have. And if you go back again, you are going to go to the ultimate home. Now if you do ls, you are going to see all the stuff that you have over here. So we have been boot dev etc means home, all these folders as regularly we have in our Ubuntu terminal. So as you can see, this is the our terminal, sorry, not our terminal, it's, so as you can see, this is the terminal, this is the actual terminal of the server. So whatever you want to do, you can perform all the tasks, and whatever you want to save or download, or if you can this will be going to run 24/7 in not in your laptop but in the server, actually running in this EC2 instance by the AWS. Okay, but as you're running they will cost you so much. So if you want to check all the stuff, you can come to this EC2 instance. So you can click on this dashboard. So you can see all the stuff that is going on here. You can see one instance is running and one volume is there, and one instance is running on all the stuff it is here. Now if you want to delete this stuff, I will also show that, don't worry. And my credit card means added, right? So this is the bill remaining I had, and 106 days remaining. And you can also check the service health, and you can also launch this instance if you want to launch that. And you can set like instance alarm. You can see what is going on in that instance, whether it is up and down, or whether how many clicks are there in that particular website that you hosted in that particular EC2 instance, and all the stuff you can view in this dashboard, EC2 dashboard. And now it's very important that you can, if you expand these instances, if you go to these instances, the main page of the instance is here. If you remember that we have named this as test. You can see the name as test. This instance ID it is showing as running. And if you want to stop that, if you double right click that, you can see bunch of options over here. You can see terminate or delete the option, and you can see an option called reboot instance, or you can see the stop instance. If you click this, it will just stop the instance, or if you click this, it will completely delete the instance. But before this deleting instance, I want to show you another thing, that you can also view the instance type. You can see there are so many instance types, and you can also see so many things called launch instance, and the spot request, and the saving plans, and request reserved instance, and so many stuff. And you can also see capacity manager on all the stuff in the instances tab. So if you close this instances tab, you have images. So you have AMIs. So there is nothing over here, and you have something known as AMI catalog. So in this also you don't need to do anything. So you can simply close these images also. And now here comes the important thing, that is Elastic Bookstore. So if you click on this volumes, you can see one volume is running over here. So this actually the amount that you have been charged for this volume only. Why? Because this is the volume that is attached with this instance. If you click on this instance, if you go to the instance, so whatever that data that you are having or storing in this test, that will be going to store in this volume. So please make sure that you also delete this in volume also. So after that we have snapshots and lifecycle manager also. You can see all the stuff here. Then you can see the network and securities. You can go to the security groups. So what are the security groups? It's nothing but what is the network ports, or what is the security ports that you are going to handle. So if you from anywhere, if you want to allow the access to your website, or from particular website that you want to accept to your website the request I'm saying about, so in that situations you can see about this. Okay, so this is very important stuff. And after that we have elastic IPs. So basically in the security tab we have elastic IPs. So here elastic is nothing but how much you go, that much you need to pay. And you have some placement groups, and you have some key value pairs. So there is no key value pairs. We have directly SSH into the terminal. You can see this is the terminal. So you can also stop that, and I will delete that. I will show you how to delete that, don't worry. So you can see we have some network interfaces also. And finally I have where we have topped and where we have took the diversion is the load balancing kind of stuff. So actually you can host your complete website in this instance. Okay, if you come to this instance, you can go to this, you can completely download from your GitHub, and you can completely host that here. That's one way. So after doing that, if you want to take another EC2 instance, and you can see If you click on here, you can see launch instance from template. You can do migrate services also. You can do much more stuff. So after you have, suppose let's say you have 2 services or 2 EC2 instances, then you can load balance them. Suppose 100 users are coming to your website, so 50 users will go to this first test instance and another 50 will be going to go to another instance if it is there below here. So that's the main use of this load balancing. So if you go to this load balancer, so right now you see nothing over here, you can simply click this create load balancer kind of stuff. So you can simply click this create load balancer. You can read all the stuff what it can do and how we can make this load balancer and kind of stuff. And it is saying that compare and select load balancer type. Okay, a complete feature by feature comparison along with detailed highlighted is also available, like that it is showing for us. So application load balancer, network load balancer and gateway load balancer is also there. So whatever the load balancer that you want, you can simply create that. So based on your usage only you are going to get charged. Okay. So simply I will be going to close this. So I hope you got the main intuition or main idea or main place where how you can create the load balancers and how you can use the load balancers and what are the three types of load balancers that the AWS provides to us. And if you go to the target groups for this load balancing, so right now I don't have any target groups. If you want any target groups, you can simply click on this target groups and you can make your custom target groups and you can see what is this trash stores. And you can also see auto scaling. So I already discussed in the system design that auto scaling and let's say you have 10 systems, let's say users are growing continuously, you have more, you want more systems. So at that situation you are going to do auto scaling. So this is also part of a system design, so also a very important topic. So it's no worry, AWS will provide complete in the it provides us auto scaling feature also. So if you simply go to that auto scaling feature, you can simply create auto scaling group. So we can create this group and we can apply to that particular test instance we are running now. Okay, you can read more about that. If you want to know about the documentation of this, you can simply click on this auto scaling button. So you can see this is the documentation only. Okay, here you can read about the pricing and all the stuff. Right now it's, as this is the basic video, so for simple understanding purpose I am making all the stuff in this simple in this Mumbai region. So I'm explaining to you. Okay, if you want to go let's say if you click here, you can this is the side panel. If you click here, you can go to the EC2. Now I want to delete this EC2 instance and I want to show you how that will be deleted. Now go to the instances. So first of all you can right click that, you see it is showing that running. So if you simply click on the stop instance, and it will be going to show you something like stopping your instance allows you to reduce cost, modify settings and troubleshoot problems. So you can stop production is okay, you can simply say stop. So this will be going to stop, saying that successfully initiated a stopping of this particular services. Okay, so you can simply cross that. Now what this is just stopped, that's it. But also it will be going to charge you a amount per month basis. So not just stopping, this mission is yours now. It is just this server is made on the AWS servers. So you need to completely remove or you need to completely terminate this. So you can simply right click that. Again you can click on this connect to that, but right now I want to show you to delete. So you can simply click on this delete or terminate this. So you can skip okay, you can remove this because I do want to shut down the operating system also. I don't want anything, I want complete shutdown. Okay, I can simply click on this terminate button. You can see successfully initiated termination. So basically it shows that this particular test instance, particular system is shutting down, but right now it is there because it is a system. So after some time it will be automatically gone from here. So don't worry why it is still here, I will be charged. So don't worry, it will be automatically gone. And I already mentioned that you need to compulsory remove this where is that, it's very important to remove these volumes also, because see you currently have no volume in this region. It's better, it's best that it has been automatically removed, because if you have some of the volumes, you need to check and remove, otherwise you will be billed. Okay, so I hope you got some complete details about this AWS. So you can simply click on here, so recently visited, or you can go to all applications, or you can click on all services. So you can see all the services of the Amazon AWS according to their alphabetical order. So in the A you have all the services and all the stuff. Again if you want to go to the home page, you can simply click on this AWS. So again you are going to come back to this AWS console. So I hope you got understood about this EC2 instance. Now I want to explain what is meant by this S3. So actually this S3 is a storage service by the Amazon AWS. So this S3 is nothing but you can watch the Amazon official video from the Amazon AWS. So basically this S3 is a bucket that where you can store data. So if you simply read the statement, store and retrieve any amount of data from anywhere. Did you notice how bold statement they are passing here? Retrieve any amount of data from anywhere. So this is the accuracy, this is the thing that they are providing to us. So this is basically to store images, files, videos, PDFs and all the stuff. If you want to store, you can use this Amazon AWS. And again, if you for creating any bucket, you don't be charged anything. But if you if you put any image, any data, any PDF inside this bucket, you are going to get charged. Again, what is this bucket? So bucket is nothing but like a database. Bucket is like a database. You are creating inside the database. You are keeping some files. So okay, let's create a bucket and let me show you something. So you can say general purpose and you can remaining keep as it is as well. So you can completely come down. You can simply click this. So bucket name is mandatory. So bucket name should be unique, I guess. So let's say for simplicity I will say Charan, and you can say bucket with the same name already exists. So you need to pick a random, not random. It's a very important point that it should be unique throughout the world. Okay, and you can simply come here. You can simply click on this create button, and it will be going to create you a bucket for you. You can see it is asking you to upload an image or any file. So basically you can store all the images, but physically we are not going to go upload images or something like from here. Why? Because if you simply upload from here, then what is the main use of using AWS Amazon? So if you want to use the services or from code, from the code, if you want to upload here, you can use all the stuff. You can see copy S3 URI. You can simply click here or copy URL, or you can download, open, and you can simply click on this action. So you have so many options. Okay, and you can do so many things and so many stuff. You can go to the metadata, all this stuff, and you have permissions, matrices, management, and access points, and all the stuff. Okay, you can again come back to these buckets. You can simply click on these buckets. Again, I have one bucket called named Charan 2666. It's my name and some number. Okay, and if you want to go to the documentation, you can simply click on this hamburger. So this is the buckets panel, files, access management, security, storage management, security. So one thumb rule, the right hand thumb rule of this using Amazon AWS is you can see all the stuff on all the what we call documentation, and all the stuff will be there inside this hamburger kind of menu stuff in this left side, and all the services will be there on the right side. So definitely please make sure you always go through this left side sidebar and check their exact documentation. Okay, if you got any doubt, so you can simply click on this bucket. So you can go to the general purpose bucket. So this is the general purpose bucket, and you can go to the dictionary bucket. So you can see there is no dictionary bucket. So in this fashion you can go to a file system. So in this fashion you can read all the stuff and you can understand what are there, what is there, what is this. So again I came back to the home page of this Amazon S3, and you can see right now I have one bucket. So how do I know I have one bucket? You can simply again click on this general purpose bucket. You can go to the settings and you can see something known as AWS Marketplace for S3. You can see storage, backup, and recovery. So for your simplicity, there are so many options you can check here. So they are saying storage, backup, recovery, production for S3. So you can go to view product, means you can go to their product and you can view that, and you can integrate this with the help with the S3, and you can also see we have some of the free trials over here also. And in this fashion you can also go to the data integration and analysis. So these are the marketplaces. You can go through these all marketplaces and how you can integrate and all the stuff. You can read these permissions for this AWS S3 also. And not only that, IAM means, let's say in your company 10 members are working, then for what user, what permissions that you are going to give or you want to give, so that and all the stuff is managed with the help of IAM. So don't worry, I will also going to show you what is meant by IAM in the Amazon AWS. So if you want to delete this one general purpose bucket, you can simply click on here. So after clicking that, you can see it is saying that you can empty this complete bucket or you can delete this bucket. So if I click this delete bucket, it will be going to delete this bucket. So but for deleting, you can see delete bucket this. To confirm deletion, enter the name of the bucket in the text field. So what is the name of the bucket? The name of the bucket is this. See, they are suggesting here also. So I can simply enter that name as well. So you can simply click on this delete bucket. Although there will be no charges for us for creating a bucket, but for simplicity, I make sure nothing is there. So I deleted that bucket. So again, I will come back to the home page. I hope you understood what is meant by S3. So you got to know about EC2. It is a complete server. You got to know about S3. Now I want to explain about you what important service, that is Lambda. So Lambda is nothing but let's say you want to just have a function that will be running in the cloud. So whenever any user call this function, then this particular code has to be run and this particular logic has to be evaluated. So that kind of functions, if you want to just manage the functions, just function code, then you can use the Amazon AWS Lambdas. So this is also one of the most used services in the AWS. So you can see all the languages it supports, like custom runtime, Python, Ruby, Java and all the stuff. So basically you need to export some kind of stuff and you can use this. And if you want to test that, you can also see you have a button called run and all the stuff it provides. And if you want to know more about this Lambda services, it says that AWS Lambda run code without managing server. See, it's saying boldly without managing server. You don't need to manage a complete server like EC2. So as I said, EC2 is a complete server, that all the thing that you need to manage by yourself. So it's a complete by your on your hand. Let's say some people just want to build a just functions, just want to use functions which are in the cloud. So they can use this make use of this AWS Lambda services. I already said if you want to know more about this, you can simply click on this hamburger. So you can go to the dashboard. So you can see based on the how many number of function calls you got, so that much cost that you need to pay to the AWS. So you can see Lambda functions. So right now I don't have any Lambda functions, so that's why it is showing 0. If you click on this also, you don't have anything. So code storage. So as I don't have any code, so it's showing 0 byte. So full account concurrency and unreserved account concurrency, so it's showing me. And number of means number of function calls and all the charts and all the stuff you can see clearly over here. Okay, so this is also one of the most used. So if you click on these applications in the Lambda, so if you want to know more about, you can simply click on here, or you can see you can create an application with the help of this Lambda services. And not only that, it is showing that capacity providers is the new thing. If you want to read more about that, you can read here a simple definition what you can do with this. So I hope you got the use cases of the Lambda. It's just a function if you want to run in that. Now the next important service that I am going to talk about is Amazon Simple Email Service, that is Amazon SES. Amazon SES Simple Email Service. So this is also one of the main used service in the Amazon, that is the Amazon SES, highly scalable inbound and outbound email service. So they are saying highly scalable inbound and outbound email service. So if you want to get started, you can simply click on here. But I already suggested that if you want to read more about that, you can simply click on this hamburger and you can get to know about more about this. Okay, you can see simply click started on this this stuff. Like I simply click it, get set up. You can see there are 6 steps total. First of all, they need to verify your email. So see, add your sending domain. So basically you need to beforely have your custom domain, your own domain. So the domain name you need to enter in this step. Okay. So after that you need to deliverable enhancement, create your dedicated IP pool. After that they need to add tenant management. Then review and get started with SES, which is nothing but simple email service. So all the stuff is very important over here. Okay. And not only that, you can go to simply go to the account dashboard, that you can see simply Amazon SES simple email service. So here you can see number of emails sent to through this particular email that I have logged in with the Amazon particular email. From this email I have nothing sent to another email, so that's showing here. And remaining sends, there are total 200 sends here you can see daily email usage. Okay, if you want to extend, you don't want just 200 email, you just want more than 200 email sending per daily. So in that case, you can go to the info and you can read more about this, or you can spend more amount to get more number of emails to get sent. Okay, you can see the sending quota and all the stuff. You can see number of sends, number of rejects. What is this rejects? So rejects is nothing but, let's say I have a domain called triplit.com. So let's say another let's say some outlook.com, and another is there at the gmail.com. So at some cases, if I send from Outlook to Gmail, it might reject. So at that cases, all the rejects will be shown over here, and the date also you can see over here. And not only that, you can also customize your SMTP settings and also all the configurations and all the stuff, dedicated IPs, and you can also read more about that stuff and global endpoints. Okay, and all the email validation. So you can see email validation and all the stuff. You can go through this mail manager and all the stuff. You got that. As this is the system design course, I'm not going in depth. So but simply I'm explaining each service, all the services I'm explaining simply, so that afterwards if I explain any topic related to the Amazon AWS, so you might not be confused in that topic. So that's why I'm explaining prior only through my account. So you understood Amazon SES, simple email service. So the next service of the Amazon is the simple notification service. Now you might wonder, there are so many services over here, but not like that. So there are hundreds and thousands of services, but I have just opened 15 of them here. So how do you know how many services that they have here? So you can simply click on this button. You can see that all services. So these are all the services. You might get lost all if you go through any of these services, because there are so many services, right? So according to your requirement only, you need to go to any particular services. Otherwise you might go out of any service. Okay. So by default, if you on any service or forgot to off any of the service, so it will be going to charge you without you noticing. After that, finally end of the month, you will be get an email that you are charged with that particular use cases. So okay, there are so many of the services, but right now I hope I have shown you four of them. I have shown you EC2, S3, Lambda, and Amazon Simple Email Service. So the next service that I want to explain is Simple Notification Service. Let's say we have push notifications, like a pop-up is coming from the email and all the stuff in your mobile. So that is known as push notification. Okay. If you want to read about documentation, you can simply click on this hamburger. Okay. It is saying that Amazon Simple Notification Service, Amazon SNS. So it is saying that pub means publish, sub means submission. Okay. So messaging for microservices and serverless applications. Okay, it is saying that Amazon SNS is a highly available, durable, secure, fully managed PubSub messaging service. So if you want to know more about this, you can read this particular statement, and not only that, you can simply go to the next steps, and you can publish your own topics also. So after that, when we see Kafka and all the stuff in this messaging queues in our system design in this course, in this stuff, so you might not confuse what is SNS. So for that reason only I am explaining this SNS before prior itself. So you can simply go to the dashboard. You can see all the topics that we have published and all the platform applications, all the subscription that we have, and you can see all the stuff, how that PubSub or how SNS is managing our resources, or how it will be managed. Okay. And subscriptions we have, how many subscriptions and all the stuff. For the mobile also we have push notifications. So here you can see we can create a platform application, and all the push notification also we can manage with the help of this Amazon SNS. So this Amazon AWS is a complete thing for your system design course. So that's why I'm explaining in detail all the services. So the next service is Simple Queue Service. So the name is So the services that I'm explaining, the name itself they're explaining, the self-explanatory they are. So that's the reason that I'm not putting any much more effect in that explaining them, because the name itself says it's a simple queue service. Simple queue service. So what is this queue? So don't worry, I will explain what is meant by queue and all the stuff in this video only. So please be patient with me. Okay. So queue is nothing but let's say there are 1,000 mails to be sent, but as your email service is very busy, so it can't send all the 1,000 messages at a time. So what it will do is it will basically keep all the mails in a queue. So it can be Kafka, it can be RabbitMQ, it can be anything. So basically it will be keeping in the queue. So it will send one by one. If any of the mail has been failed to send, so again it will be pushed back to the queue, and it will be going to try again to send that queue. So after a particular time of you can remove that if it is that not sending. That is the main intuition of how queue works. Okay. So queue works in not only mailing system, you can also use there are so many use cases of using this queue services in the AWS. So again, if you come back here, so we have understood up to SQS, that is simple queue service, and now we need to understand what is meant by elastic cache. So I hope you know what is meant by cache. So cache is nothing but if you store data. Okay, if you store data in between your browser and front end, like let's say you are storing the data in the form of key value pairs in the Redis. So that is also one type of cache, but in the Amazon we call it as elastic cache. So then it's a fancy that Amazon keeps for all its services called elastic. So elastic is nothing but you can based on your usage you are going to build. So that's why they named it as elastic. So that is a cache service. That's why they are saying cache. So cache is nothing but to improve your fastness. So you are going to store some data in your browser, in your front end. So that data is known as cache. So you can also get started in this cache, and you can explore all the stuff what is there, and what you can explore, what you can do, all the stuff in this cache. So you can also see Valkey cache, Mem cache, Redis OSS cache. So most of the developers like to use this Redis OSS cache because this is one of the most preferred or used Redis cache in the applications in the real world. And you can configure this cache. You have subnet groups, you have parameter, usage management, user group management, and all the stuff you can see clearly over here. If you click here, you can see all the stuff. You can create a cache also here. Okay, if you want to read the documentation, again you can click over here and you can read all the documentation of the Amazon AWS. And again, you can, if you want to go to the home, you can click on here, or you again go to the home. So you understood what is meant by elastic cache. Now it's time to understand Amazon document DB. So what is this document DB? So my friend, if you don't understand anything, so don't worry, please stay with me. I will be going in this video only, I will going to explain what is meant by this document DB and all the stuff in this video only. But for simplicity, so I just wrote down, I'm just showing all the services of the Amazon which are very famous, and in the further discussion also we might encounter this kind of stuff. That's why I'm saying first of all at prior only. So Amazon document DB. So I hope you heard about the MongoDB. So as MongoDB will store the document like in the form of document. Okay. So it is not relational database, it's a NoSQL database. So the alternate of the MongoDB is Amazon document DB. So it says that with MongoDB compatibility. Okay, so you can also use the MongoDB also inside, like it's a compatibility, right? So fast, scalable, highly available document database, it is a so available and fully managed document database service that supports MongoDB workloads. So you can see MongoDB workloads. So you can simply create a MongoDB cluster inside here only. And mind you, so whatever the database kind of thing that I'm storing, that is very expensive. I mean, very expensive out of all the services that I'm showing. So you can see 30-day free trial. After that, you are going to go get charged in this manner. So 750 hours on T3.medium instances, you are going to go get all this stuff here. So you can simply read how you can manage all the stuff here. Okay, and you can simply click on this dashboard. So you can simply came here to the dashboard. So what are the clusters that I already have created? So if you have before worked any experience with the MongoDB, you will understand what is meant by cluster and what are all this stuff. So cluster is nothing but a database that you are going to store all the data here, and you can create a cluster also. But I'm not going to do that because it's very costly resources. So you don't need to waste your resources, right? So I have so many stuff. Okay, it's not AWS video, so that's why I'm not explaining in depth here. So you have understood Amazon document DB. This is one of the costliest service, and you can see S3. This is one of the costliest service out of all these services. Now you have understood all these services. It's time to understand these services also. Here we have something known as Aurora and RDS. Okay, so RDS is nothing but relational database. We have SQL, PHP, PHP not Postgres, and all this stuff we have, right? So those are known as the SQL, like it's a Excel kind of thing. You can store your data in the form of the Excel table format. Okay, you can see Aurora and RDS. So we have dashboard. So this is the dashboard. You can see you can create the database, but I already said whatever the stuff is related to the database, it is very costly. So don't make until unless you want that. Okay, so after that we have something known as databases. You can see that I don't have any databases right over here. So you can expand here. You can see full configuration or restore from S3. So you can also get that from S3, but I don't want here. You can also click here and you can create that. So you can go to the let's say you got some data. You got some data from your backend. Okay, programmatically in the code way you are getting something data, like you got something data here. Then how do you know that data has been added or not? So simply you can click here. You can simply, if you click here, you are going to see some reload here, and you are going to see if any of the new data has been populated. Then you can see all the data will be getting over here. So this is the reload button to get new updates over here. And not only that, you have performance insights and all the stuff. So again, if you want to see that, you can click on this hamburger icon. So there are so many options, but I am not going to go through all these options. But simplicity, I am just exploring this Aurora and RDS. Okay, this Aurora is also a relational database which stores data in types of table. Okay, so the next few services that I want to discuss is, the first service is CloudTrail. So what is this CloudTrail? So this CloudTrail that we need to understand is it's also one of the very important services that most of the developers like to use these services. So you can see AWS CloudTrail continuously log your AWS continuous activity. So let's say in your account in the S3 someone has created someone has created a bucket, someone has deleted a bucket. So that's only right. Interns, if you give access of the AWS, they will be going to create, delete, and all the stuff, that kind of stuff. It will be happening over here. So it will be never happening in the big tech companies. Why? Because in the big tech companies they will be make sure that the permission of creating and deleting a database is not allowed. That we can configure that details, and we can apply on that particular user, on that particular intern. I'll also show you how we can create that particular group of rules, and we can apply it to that particular person. I'll show you that. But before that, let's say let's say you are the owner, you are the CEO of the, or if you are the owner, or in your company some correct person only you have given the access of this any S3, but unfortunately he have deleted some of the database that he felt it was unnecessary. But after some time we know that services or that particular data is very important. So if you want to track that data, or if you want to know who has deleted that data, so for that purpose you can use this AWS CloudTrail. So it will be going to say that continuously log your AWS activity. Okay, it will be continuously going to particularly going to see your particular AWS activity, why it is going on each and every services. Okay, and it will be going to I will show you where it will be going to show you all the details. Okay, and you can see it is showing that create a trail. So it will be going to trail all your track your all the data, but it will be not going to display all the data here. So if you simply go to the dashboard, so this is the dashboard. You can simply create the trail, and you can use the stuff also. So you can see all the event history that I had. You can see. So up to now I have did these many stuff. So you can see the last stuff that I did is delete a bucket. You can see s3.amazon.com. I have deleted that. Why it is showing here? Because right now, so July 8th, today I have deleted a bucket right now in front of you just before some time. Okay, so not only that, I have stopped the instance. So I hope you this makes some sense. You understood, right? So all the activity that what you are doing in this AWS, that will be going to track all the stuff here. Okay, and the resource name, I have deleted that bucket name called Charan root 666, and I have resource name here. I have stopped the instances called this thing. Okay, if you want to completely clear filter, you can also see all the stuff. Okay, you can also, if you want to delete anything, you can simply click here, and you can see clear all selections. Okay, you can simply click on here. It will be going to clear all the sessions for you. Okay, this is the main important tab, that is event history. So you can also see the resource name and the event source, and who is the user, the root user or the actual user, or the user ID who deleted or who did that particular activity. You can see here. Okay, so I hope you understood what is meant by CloudTrail. So you have understood what is meant by CloudTrail. Now it's very important to understand what is meant by CloudWatch. There is a subtle difference between CloudTrail and CloudWatch. So CloudTrail will always track your AWS activity, but this CloudWatch, what it will do? If you want to understand, you can go to the dashboard. So you can see right now I don't have any particular dashboard. You can create your custom dashboard. Okay, so if you again want to read the documentation, you can come to this CloudWatch. So you can see configure the CloudWatch agent to unlock enhanced monitoring capabilities for your EC2 instance through a streamlined configuration flow powered by workload detection. You can easily set up customized metrics that matches your specific workloads, so allowing you to gain deep insights into your infrastructure like this. Okay, so if you want to see that, you can see create and name your CloudWatch dashboard. Okay, you can see, so you can set of your any of the matrices and all the stuff. Okay, so just before I said one thing, so whatever the thing that is managed by the CloudTrail, okay, that all should be put in some place. So that place is here. And another thing is, and whatever the user management kind of stuff, that also has to be managed. Like you have 100 employees, or you have 10 employees, that all the employees has to be managed. So all the employees can be managed with the help of these services. You can go to the AI operations. You can read about that stuff. What is this AI operations, Gen AI observability and application. There are so many things. See, you have something known as logs. So you can go to the log management. So if you go to the log management, right now I don't have any log management, but you can manage all the logs from here. And you can go to the network monitoring. You can see all the flow monitors and all that kind of stuff. Okay, you can read all the stuff, or if you want more thing about, you can read this particular, or you can see this particular video on the YouTube. So again, if you go to the AWS homepage or the console, this is known as console, right? So you have understood what is CloudWatch, CloudTrail, and all the stuff up to here. Now it's time to understand the container services, like Docker we have, or we have Kubernetes, that kind of stuff. So those are particular private services, right? Private services run by the Docker, run by the open source community Kubernetes, that kind of stuff. Don't worry, I will explain the Docker and Kubernetes service in this video. So, but before that, so what is the alternative that we can use in the Amazon AWS? So the first services is Elastic Container Service, ECS, Elastic Container Service. So if you simply go to that, so again, this is also one of the these three are also one of the costlier services, because you are managing some of the data. So if you create a container, and inside that container, if you are having some of the volumes, so that volume you need to manage. So for that also you need some of the amount money. So please make sure according to your requirement only you create this particular container services, right? So this is the replacement for the Docker. See, it's saying that Amazon Elastic Container Service, ECS. Saying that fully managed containers. So you can simply click on this get started button, and you can simply create you can create the containers and all the stuff. You can pull the images and all the stuff. You can see clusters, task definitions, daemon task definitions, and all the stuff. Okay. And if you, let's say you have an image, and if you want to pull that image to the AWS, so for the Docker we have Docker Hub. So in that same fashion, for the AWS we have something known as Elastic Container Registry. So let's say it's like a registry in the Docker Hub. In the Docker Hub we have registers, right? So if you have worked with the Docker Hub, you might know there is something known as Docker Hub. Inside that there will be registers. Inside that registers nothing but folders. Inside that folders you need to store some of the data. So here also we have something known as Amazon Elastic Container Registry. So share and deploy container software publicly or privately. So both publicly and privately you can share your images and take images, push, publish images, and you can play around all that stuff with the images. So you can click on this repository. Right now I don't have any repository. You can simply create repository. For creating a repository there is no charge. But if you store any of the information, any image inside this repository, you will be going to get charged. So I will be going to simply click this cancel, because it's a demo video, right? And you can simply click on this again repository. You can see that same thing. You can go to the settings and you can change and edit the configuration that you want. And the final service that I am left with want to discuss you is Elastic Kubernetes Service, right? So we have understood what is meant by Elastic Registry. It's like Docker Hub. We understood Elastic Container Service. It's like Docker. Now actual Kubernetes, we have the alternative called Elastic Kubernetes Service. So if you simply click on this Kubernetes, Elastic Kubernetes Service, EKS, so you can see you go to the dashboard. So for hiding and seeing the documentation of this, you can simply click on this hamburger. Okay. So again you can go to this dashboard. So it's saying that in my current region I don't have this Kubernetes service. So okay, I don't want that, so I simply cancel that. So you can go to the dashboard settings. You can go to the console. So basically it's a Kubernetes running on your cloud. Okay. So again I came back here. So right now what are all the services that you are seeing here? These are running in the cloud. So for all these services you need to pay money. Okay, but one service I forgot to mention, that is IAM. So you can see, so it is saying IAM. So if you simply go inside that, so this is the last service that I want to discuss with you in the AWS. So after that we will be again going to proceed with our PDF, so that we can understand the system design concepts. Okay. So actually all the implementation of the system design concepts are done in this AWS. So that's why I am implicitly taking this much time and explaining the interface and all the services of the AWS. Okay. So you can see it is saying that IAM dashboard. So IAM is nothing but the full form of IAM is identity and access management. As I said before, we should be aware of the groups, and we should make some permissions on the groups. Okay, you can create a groups, you can create permissions for the groups, and you can assign a particular task for the group. All the stuff all your staff in the company can be managed with the help of this IAM dashboard. You can see you have a roles. So you have some roles, you can create a role and all the stuff. You have some policies, you can create a policy, and you can apply this policy on particular group. Okay, there are so many policies. You can ignore this. So next I am user. So right now I don't have any user, because I am a root user. I did not create any of the user. So because it's for demo purpose, it's a account which has been not used. It's used for recording purposes. So next thing is I am user groups. Next identity providers. Next account settings, and there are so many bunch of options that you can see over here. So this is also one of the most, IAM is also one of the most used services in the AWS. Okay, so I hope you understood all the services, and you can see simply click on this view all services button also, and you can simply view the services also. So now I want to go through you the as I deleted that. So this is the AWS document database. Where is that EC2 one? Okay, I will simply search that EC2. So you can see this is the EC2, because I want to show you that it has been deleted or not. So if you simply go to the dashboard, so you can see 0 instance has been running, as I said before, and you can see one instance it is showing 1. If you click on that, it is saying that it has been there, but it has been terminated. Again, if you again particularly want to again re-delete that, you can simply click here and you can simply delete that. Of course it has been deleted, but for your safety purpose, you again want to delete that. I think it will be going to take 4 to 5 hours, so that's why it's not been deleted right now here. But according to the current situation, I hope you got understood about all these services right now. So the next part or the next section in this video that we are going to understand is reverse proxy and forward proxy. So what is meant by this reverse proxy? So we will be going to understand here in this fashion. Let's say this is your server, and let's say these are the servers of the actual company. Okay, so not your server, this is you. Okay, this is you, these are the users. Let's say I will be going to represent the users as circles, so that there will be no confusion in this fashion. Okay, so in this before sessions, what happens is, so actually the forward proxy is nothing but you are going to directly send your all the requests to all the servers. So this is one of the worst way of representing or the for doing your let's say this is the user and doing request. So this is one of the worst way of doing direct request. So you should not do direct request, because it will be something like there will be load balances in between, all the stuff will be there. So reverse proxy is nothing but, so this is the first of all you are going to do forward proxy all these requests. So forward proxy is nothing but you are directly going to send all your requests to a server. So this load balancer, what it will do, this will be going to split all your requests to a particular server according to its particular configuration. It will be going to redirect to you to the server. Okay, which server is active based on so many parameters. It will be going to judge for which request which server has to be responded. Okay, this and all stuff will be done with the help of this load balancer. But there are so many stuff that can be helped with the help of Nginx. Okay, this single Nginx can be performed load balancing. Okay, this Nginx can perform load balancing, because as you can see here, so many requests has been processed to the so many servers. So this is known as load balancing. At that time it is also known as reverse proxy. Okay, because see you can see here the server does not know from which user the request has been coming, because here it is managed by the help of this load balancing. Okay, and the user also doesn't know for which server his request is going, because it is going to the load balancer. The load balancer, it is splitting that in the reverse fashion. So we are getting the request, so it is known as reverse proxy. Okay, so the single Nginx services, it can also provide the load balancing, it can also provide you reverse proxy. Okay, these are the two main important concepts in the load balancing that you need to understand. So again, if I come here, you can simply read the definition of the forward proxy and reverse proxy. So forward proxy is a sit in front of the client. Okay, hides the client from the server, hides the client from the server. And what is reverse proxy? Sits in front of the server, not the client. Okay, sit in front of the server, hide the server from the client. Like we can see Nginx, we used LB, SSL termination and caching. Okay, you can see the Nginx logo here, and you can see the these are the clients which are with the help of this load balancer we can do the load balancing and the reverse proxy as well. Okay, this load balancer also only will act as a reverse proxy kind of stuff. See. So forward proxy is nothing but you send here and all the requests will be forwarded, and reverse proxy is nothing but you will get multiple requests and it will be managed to a single means multiple servers over there. And if you want to understand what is meant by the reverse proxy, API gateway and the load balancing, so you can understand the reverse proxy, API gateway and load balancing. So reverse proxy is nothing but this is the client. So from the client you are getting request and you are going to the server. Okay, and it says that hide service address. And in the same way, API gateway is also getting a request from the client, and it will be going to go to the particular services or the server. And we have single point of entry, and we have something different APIs. Okay, so for the server we have separate API, for the server we have separate API, for the separate server we have separate API. So for separate APIs we have something known as gateway, API gateway. Okay, and finally what is load balancer? Load balancer is the same thing. So which will be going to handle the load, and it will be going to send particular request to the particular service that is known as load balancer. Okay, you can see request coming to the internet, going to the reverse proxy, going to the web service. So this is the way how load balancer or the reverse proxy works in hand. And the next section that we are going to talk is section 6, that is the CDN. So here CDN is nothing but a content delivery network. So what is this content delivery network? So as we already discussed in the EC2 instance, EC2 instance of the AWS, so that is very important that that content delivery is nothing, will handle all the images, files and all the stuff that is working near you. Let's say I am staying in India. So in India, where is this particular content delivery system? There is one big server. From this one big server, we are getting to the small server, that image files and all the stuff. From there, we are getting all the stuff to our computers or the browsers. So this is the how the way that content delivery network works. Okay. So caches static assets like image, JS, CSS, and edge location near users. Okay. Reduces latency, offload origin servers. Okay. Example, we have Cloudflare. This is one of the most used kind of thing for using the content delivery network or the reverse proxy, that kind of stuff. Okay, for the content delivery network, Akami. Okay, then next we have Cloudflare. Okay, at final these are the CloudFront. The next important section that we are going to discuss is section 7, and the next section that is the difference between SQL and NoSQL. So we understood that a simple difference between SQL and NoSQL. So basically SQL stores your data in the form of tables, and NoSQL will store your data in the form of documents, key value pairs or the graphs in this format. So according to your requirement only, you need to choose whether you want SQL or NoSQL. Most of the banking applications, that kind of stuff, will use SQL, and if they want the data as a table format, in a clean format, or if they want to process the data in a clean way, they can use the SQL. Or if they want flexibility, if they want the more number of fields or dynamic data, or they don't know whether the field will be added or not, in that situation, they can use NoSQL. It's no wonder that in many big tech companies they will use the mix of the hybrid of SQL plus NoSQL. How? Because in some of the situations they will use SQL, in some of the situations they will use NoSQL in a single company, in a single platform. It is possible because this will be going to run in one service and this will be going in another service. The ports are different, the requests are different, all are different. So there is no issue in maintaining two services or two servers at a single code or single platform. Okay, you can read the difference between this in the table. It has been particularly mentioned over here. What is the exact difference? So you can read SQL databases are the relational databases. Here relational means it's a table format and structured. Okay, table based, while NoSQL databases are the non-relational, flexible and distributed systems. Okay, and if you want to see the table difference table, we have table with fixed and rows and columns, dynamic schema, and in the SQL we have relational model. In the NoSQL we have no relational model. And in SQL we have a vertical scalability, like vertically we can scale. So I explained you what is meant by vertical scaling and horizontal scaling. So that comes here. Okay, we have horizontal scaling here, and not suited for hierarchical data storage. And this NoSQL suits for the hierarchical data storage. Hierarchical is nothing but, I hope you know about the trees, which will store the data in this format. So I already explained you, if you want to store the data in form of trees, so then you can go from the NoSQL database. So that is known as hierarchical. Okay. So examples are, we have SQL, MySQL, Postgres, Oracle, this kind of stuff. And in the NoSQL we have MongoDB, RavenDB, LightDB, and Amazon Aurora DB. I have shown you that. Okay, or RDS. In the AWS I have shown you. And in the DB, while you are working with the databases, if you want to have good system design, you need to you need to see all these stuff, all these trade-offs and all that stuff. So the first one is indexing. So you need to make sure that you need to have the B-tree index default in most DBs. So good for range queries. Okay, if you want to have faster queries and all the stuff, and we have something known as hash indexes, trade-offs and all the stuff we need to take into consideration. And another thing that we need to take is sharding. So horizontal partitioning. Okay, so split large tables across multiple databases servers by the shared key. Okay, this is one important point. And the next important point is strategies. Okay, we need to keep in mind that a good strategy will have your good system design correctly, and we need to consider all the risk, what are the risks and all the stuff. And we need to make sure our database is replicated already, and we need to make sure master slave strategy. So what is meant by this master slave strategy? So one master will be going to control all the slaves. Here you can see this is another slave, this is another slave. And what happens is, if you want to perform any read operation, you can perform from this any of the slave, you can perform read operation. But if you want to perform any write operation, you can perform the write operation in this master, so that the consistency of the data will be performed correctly. And the next thing that you can make sure is MongoDB object ID and MySQL auto increment. You already explored this. Okay, how? How means the object ID. What is this object ID? Let's say user1, user1, and if you want to track all the users, that kind of stuff, that is with the help of the object ID. Okay, and auto increment feature, this is for the NoSQL, and this is for the SQL. We have something known as auto increment. As it is storing in the format of the tables, we can have the incremented like 1 2 3 for the user 1 user 2 like that. So this is known as auto increment. Okay, and the next section that we are going to discuss in this system design is, that is, if you come down, that is known as caching. So we have already explored what is elastic cache in the AWS. Okay, and if you understood that what is cache, let's say this is the browser, so this will first go to the cache. This is the cache, and from this cache you are going to go to the backend. This is the front end. So the first what will happen is, it will be going to go to a request there, and in the cache you will see there is nothing is there. So cache will call this. So cache will get data from the backend. This is the backend, and this is the front end. Okay, cache will get data. Let's say I will call it as data, and it will store this data temporarily in the cache, and it will be going to return this data to the front end. So whenever the same data is requested again, so it will not going to go call this backend again and again. So whatever data it has been stored inside it, it will be going to directly return from here only. So this is the main use case of cache. It will be very fast, very fast. If you are already familiar with cache, you know that. And one of the most popular cache providers is Amazon EC, that is Elastic Cache, and another one is the Redis. Okay, you can see the write to the cache and DB simultaneously. Okay, consistent but slower writes and back write. And e-victim policies, we have LRU cache, LFU cache, TTL cache, means best expiry, least frequently used, least recently used. Okay, this is the common kind of stuff, that how you need to use, or how you can use the cache. Okay, cache, this Redis will store the data in the form of key value pairs. Okay, if you want to know more about cache, you can comment down below. I will make a separate dedicated video on this Redis. And or if you want to know more about this, you can read the documentation official of this Redis. And if you come down a little bit, you can see the diagrams how the cache works. I already explained before. Cache, the request will be going to directly hit your laptop from the database, but if you have cache, that will be going to store that in the cache fast and temporary. So after, if you shut down this, and this cache will be going to remove all the stuff from the database. Again, if you start the computer, the whole stuff again, first of all it will going to go here, it will come here, and it will re-request will be faster here. And if you see here, this is a very general kind of scenario that we have. But if you talk in terms of the Amazon AWS, this is the Amazon API gateway services. So in this we are going to go to the Lambda services. I hope you understood what is meant by Lambda service. I explained you in detail the basic stuff, and we have some services over here. We have some system records, applications, and services. Okay, we have some Elastic Cache service, cache manager, and all the stuff, and we have Amazon event bridger. So a cache manager will come here. Okay, so first of all, what will be going to happen is, it will be going to check in the Amazon Elastic Cache. If the data is there, it's okay, and you will be going to get the data from here only. If that's not the case, it will be going to go to the database, and it will be going to store that in the. So, and in the Redis we have something known as write through and read through. So write through means we have cache, app, and database, and read through means we have database, cache, and app. So how the requests are handling, you can see. So the first of all, write through means, first of all, from the app we are getting data from the cache, and in the database also we are getting at the time same populated the data at the same time. And in the read through means we are getting data from the database to the cache, and cache to the app. And the write behind, write around, write cache ahead, pre-fetch, and all the stuff you can clearly read over here. You can pause the video right over here, and you can read all the stuff. If you want, I will remove also, and you can understand. Okay, I just basically mentioned about all the cache services. Okay, and if you see clearly, we have something known as cache, like Redis use cases. We have Redis support like many data structures out of the box. So we can store string, number, and any of the data in the form of key value pairs. And if you see the real world applications, we have the distributed locking, counters, and rate limiting. And this rate limiting also is a very important topic. What is this rate limiting? Is nothing but, let's say you have an API. So for this API, you are required to handle only 100 requests per second. So this is known as rate limiting. Only 100 requests per second is the rate limiting. You are rating the limit with the help of 100. Okay, and we have leaderboards, session stores, messaging, and inventory management. And you can see we have the string, integer, hash, bitmap, list, and the zset, and the usage also. You can see all these three here, and the shopping cart, user retention, message queue, rank leaderboard, session. All for all these stuffs we are going to use the Redis. Keep this in mind. This is also very important. If you want, you can also pause the screen and you can take this shot and you can read it apart after that. And again, if you come down, and I also don't want to keep this as simple as that. So I also written down a code part for you. As your developers, we need to know a code like Amazon Web Services. Here also you need to understand the code part, that how you can integrate the Redis with the Node.js and how you can integrate the Redis with the help of the Spring Boot. So you can see you are getting the get user. So after that you are calling the Redis client and you are storing that in the cached. So inside that you are passing that user ID, and if cached is there, if this cache is there, you are passing that from string to the JSON format. Okay. So after that you are taking the user and you are finding that user and you are setting that in the Redis. You are setx means you are setting that Redis client in the you are setting that. Okay. So in the same way you can see we have an annotation called cacheable. In that we have something known as value as users and key as ID that we are passing, and we have got the user ID. So with that user ID we are returning that from the user repository. We are finding that with the help of ID, and or else we are throwing a new error that ID, with that ID we are not found that. So that's the main thing. That's why I like the Spring Boot, that with the help of this simple cacheable line we can get all the data instead of writing all these code. Okay. The next section that we need to understand is section 9. In the section 9 that we need to understand is about message queues and async processing. So what is this message queues and async processing is like why decoupling services and observe traffic spikes and retrieve failed. So jobs event driven architecture. Okay. So we have something known as Kafka. This is the first of all, this is RabbitMQ. And this is RabbitMQ. This is the logo of the RabbitMQ. So what is the queue? I hope you know, you have read about data structures and algorithms. So in the data structure algorithms, queue is what? Queue is FIFO, first in first out, right? So whatever the data is coming first in this fashion, let's say 1 2 3 4 5, so the first one will be served first, the next one will be coming out third, next, like this. So whatever in this fashion, not only the numbers, let's say this is the mail 1, this is the mail 2, mail 3, mail 4, mail 5. So first mail will be gone out, this first mail will be served first, second mail will be served next mail will be served next. So this we also saw simple mail service, simple notification service, simple email, this is what queue service. So all these three services that we have clearly seen in detail we have understood these three services, that is SNS, SES, SQS. So the messaging queue part and async processing part comes under SQS, that is simple queue service. So we have understood what is queue, and one of the important queue the platform that we can use is one is Kafka, another is RabbitMQ, and they both use something known as pub/sub pattern. So I already showed you what is that as in the SQS, that they are showing option called pub/sub. So pub means publish, S means like subscriber. So the publisher will be, first of all the subscriber will subscribe to that, and whatever the publisher will publish, that will be going to reach the subscriber. Okay. The publisher whatever, if he publishes something, and if he publishes a topic, if he publishes the topic, then he will subscriber will reach this is the shortcut, this as sub, and this is known as pub, and this combinedly we call it as pub sub model. And the publisher will publish, and the subscriber will reach all the data. One producer, many consumers. You understood? One publisher, many subscribers, or many consumers, that we can understand about that. And as I said before, we need to understand a small code snippets also, so that don't worry, I will be going to give this PDF in the description box. Please check it out. If you have any doubts, please comment down below. And we have something known as Node.js producer, and this is the Kafka for the Node.js. Okay, this is for the producer. This is for the producer of Node.js code. So we can see always you need to put await, and we can say producer dot, and we can say topic and message. So topic is what? Or topic is order events, and message we can say as, so value is json.stringify, and in that we can pass order ID, order status as created. Okay, as this is the producer dot. In the Spring Boot for the producer, that is Kafka producer, how we can do is the auto white, which is that we are going to do the injection. Okay, so we can say that a private Kafka template, and that you can see as I'm creating a pair of order kind of stuff, which is the name as Kafka template. So here we have a method. Saying that publish, like public void publish order created. This is a method which is accepting an a event, and we are saying that Kafka template dot send. See here, this is the Kafka template dot send, and order event get order ID and event. So this is the stuff that we are able to produce with the help of the Spring Boot. Now how the consumer can able to receive that. So let's say in the Spring Boot, if you are a consumer, how you can consume, or if you are a subscriber, how you can consume that. So with the help of the simple annotation, you can consume that. So you can see we can have this annotation called Kafka listener. So we can mention topic as order events, and group ID we can say that inventory service. Okay, and we have method called consume. So inside that we will get an event, and we can say inventory service dot reverse stock, and we can say this event dot get orders ID. This is as simple as that. We can consume the Kafka topics. Okay. So you can see this is the one of the RabbitMQ kind of thing, that this is the producer service will go here. Producer service, all the different kinds of producer services will come to this default exchange. So from here, one service will go here. It can be mail or anything that can be. Another service will go here, another will go here, and another service will go here. You can see all the different queue services. This is one of the queue service. This is another queue service. This is another queue service. This is another queue service. Okay. And this will be going consumer 1, consumer 2, consumer 3, consumer 4. So in this fashion, how the RabbitMQ works. Okay, this is all about queue in the system design. Queue is very important. If you want to know more about that, you can go to their official website of the RabbitMQ. You can read more about that there. And not only that, if you want to see overall picture of how queue works, so this is the overall picture. You can take in the the PDF that I'm giving in the description. So first of all, we have producers. So we have producers, which has producer are nothing but, like, let's say a click, let's say a event click, or a button click, or a scroll. Let's say we have a scroll, or we have a trigger. Let's say user purchases a course, then that is a trigger. That is a trigger that we need to send an email to that user. So these are known as producers. These are known as producers. Who is subscriber? Subscriber is the coder that accepts that events. Okay, all the producers that clicks and all the stuff happens in the browser will go through this message queue. Inside this message queue, there are so many messages are in ikhatta ho gaya, we call that, as means all are stacked in a line as a queue. So this first queue will be served to the consumer one. The second one will be consumed to like end consumers. Okay, there are 20 emails, so we can have a rate limiting also for this queue. Rate limiting is nothing but at a time we can send only 25 emails per minute. So this is the rate limiting kind of stuff. Okay, it can be a simple email service or anything, not only email service. We can have a notifications also. We can push the notifications into the queue also. Okay, there are so many services as you've seen, right? Simple notification service, simple email service, simple queue service. Okay, anything can be possible in the Amazon AWS. So that's why I showed you before in the Amazon AWS console. So if you see the queue architecture, if you at a whole picture, if you see the push based mechanism. So what is meant by this push based mechanism? So whenever this producer is creating something, the queue will take and directly consume. It will throw on the consumer. So this is the push based. You are pushing, it will take. Pushing, take. Then what is meant by pull based mechanism? So pull based is mechanism nothing but consumer will auto direct, means it will always trying to pull to the queue. It will check whether I have a data. So actually I will not recommend to use this pull based mechanism, because you are wasting the resources of the consumer. You are always talking to the queue that I have any data or not in this fashion, even though the producer is not producing any data here. Okay, this is one way that pull based and push based mechanism of the queue. Now the trade-offs also you need to understand what is push based mechanism, pull based mechanism. So you can simply you can read off the trade-offs that in the push based we have real time, low latency, complex, harder to scale. In the pull based mechanism, which I don't recommend, is consumer control. Like you can control that. You can check whether you let's say in the particular instance you need to check that you have any data or not. You can check that. That's very as simple as that. And next important point is it is very easy to implement. And these 2 points, due to these 2 points, I will never recommend to use this pull based mechanism. Okay, and next if you come to this RabbitMQ, an example, if you this is a queue example that I want to say. Let's say we have a function which which is as a click or a scroll, as anything which is produced by the producer. So this will be like you have a function something like this. So queue dot push, okay, something like this. So this will be going to push into the RabbitMQ broker. Okay, you have got that into the broker. So here we are going to have the exchange, and we are going to push that into the queue. So different queues that we are going to maintain and push into that. So after that, from one queue you are going to have different consumers. Okay, so these all consumers will be like, let's say /register here, /business logic here, and any heartbeat kind of Heartbeat means whether you are running or not, whether my application is running or not. That also we can check with the help of this queue. Okay. And let's say your queue service is dead for some reason, so for that purpose also you need to maintain something. Let's say you pushed that, and DLQ is nothing but dead lock queue. You can see dead letter queue, so not lock, dead letter. So let's say this queue has been failed, that's the reason it has been locked, prevent duplicate processing. So what happens is it is again taken back and put it into that queue. So this is the one of the main advantages that that is the using the queue services. Okay. And you can see simple architecture is built in, like single broker, easy to implement, high scalability, reliable, fault tolerance, and all this stuff. And you can see key matrices, we have all this stuff. Okay. Let's see the next services that we need to understand in the section 10 is that if you scroll down, that is the microservices versus monolith. If I want to explain what is meant by microservices and monolith, I want to explain a simple example. Let's say I am a fresher. I am in the first year or the second year like you. So what you do, you first learn the front end, like HTML, CSS, JavaScript, and later you learn the backend, and later you learn the database, and later you learn the connection between these two, and you learn the Docker, and you learn some of the other of the platforms, and you learn how to deploy in the let's say hostinger with your own VPS. Let's say you know how to host your VPS in the hostinger, or let's say in the Amazon AWS. Let's say you in the AWS. Now my question is, this and all the stuff is known as monolith. As a fresher, monolith is nothing but a single server. As I showed you already, that let's say you are let's say this is AWS. You bought an EC2 instance. I showed you the mission is of 2 GB, one CPU. So this is the specification of this mission. Let's say you want to scale this mission, you can scale this as vertical scaling. You can do this as vertical scaling, that is EC2. Let's say this is as 16 GB and 2 CPU. This is the bigger mission as compared to this. This is known as vertical scaling, that we have already understood. Okay. Now why I am again discussing this? Now why I am discussing again this is, so if you are doing the vertical scaling, so this is vertical scaling, this is known as single monolithic code. So monolith, the name it says mono, it's nothing but a single repository that contains all code. So the whatever the repository which contains all the code for your software, that is known as a monolith. Or we can simply sometimes someone call it as monorepo. So monorepo is nothing but all the code is there present in the single repository. So this is I will explain with the help of table what are the use cases, how you can get achieve with this. Okay. And the next one is microservices. So what is this microservices kind of stuff? So let's say this is the single code. In companies you will going to see this, but in the like you pressure, you will not definitely see this, because you don't need this, because let's say for your portfolio website, this kind of stuff, you don't want any big flashy kind of 2 servers, 3 servers like that, you don't want. Let's say this is my first EC2 instance, this is my second EC2 instance, EC2 like second instance, this is my EC2 third instance, like that kind of stuff. This is my second third like this kind of stuff, and I can have a load balancer, and for all these servers I need to manage differently. Okay. For all these servers I need to pay my amount, huge pay, but high availability. Okay, you can see high availability. But here, as you are having only one server, one EC2 instance, if the single EC2 is down, whole your application is down. Whole your application will be down. But if this here, this is down, this is there. If this is down, this is there. This is the fashion that you are going to run in this fashion. Okay, this is known as microservices architecture. So again, if I come here, you can see in the monolithic architecture, so we have user interfaces, business logic, access data layer, all are connected database directly. But if you see the microservice architecture, so we have microservices connected to a different database, here different database, another server here, another server here. Okay, you can see different databases, multiple databases. It's a big thing. It's a big thing. Like a big companies, big techs want to move from monolithic to microservices after they gain more popularity kind of stuff. Okay, you can read the stuff over here. I hope you got that. What is the difference between monolithic and microservice architecture? If you want to know more about these two differences, you can simply read the differences. First of all, the difference is code base. So in the monolithic, we have single code base. In microservice, multiple code bases in the multiple servers. So the database is single shared database and we have in the microservice we have decentralized database. So deployment all or nothing, like full redeployment. So at a time in a single as we are having only single code base, it's a single, you can redeploy it, and how many times if you want you can deploy that many times. But in the microservice it's not like that. So independent deployments has to be done because you have multiple servers, right? And the scaling, you can do horizontal scaling, here you can granular scaling or specific services. Okay, so tech stack, so standardized on one technology, this is known as polyglot. So different tech stacks you can use, like, and you can use Spring Boot, Mount Stack, all the stuff in different stuff in single technology. Okay, so this is low complex, this is high complex. Of course you are using multiple servers, so you need to connect all of these servers at a time. This all has to be consistent, right? So some data will be there here, data will be here, some data will be here. If write is happening in this thing, so you need to make sure write will be there here also, here also. So this is the main important stuff that it is making complex for this microservice architecture. Okay, and fault isolation you can read here, and team structure, large cross-functional team, small autonomous specialized teams. Okay, so cost is predictable and very low cost. So high requires DevOps infrastructure, you need to have DevOps teams and all the stuff to maintain this highly available microservices architecture. Okay, and the next section, very important section, that is section 11, that we need to discuss here is about the API designing. So API designing also a very important part in the process of creating a good system design. Okay, if you want to have a good system design, if you want high availability, so your APIs has to be hit by the user faster. So good API design has to be there. So for that purpose you need to have a clear understanding of what is meant by REST API, SOAP, WebSocket, webhook, what is webhook, so what is GraphQL, gRPC, WebRTC, and Graph API. Okay, out of all this stuff I will mostly recommend you to mainly focus on this REST API, WebSockets, and this GraphQL, and webhook also. So basically this GraphQL was introduced by the Facebook. If you understand the timeline of this so that you can understand clearly, first of all there we have the REST API. So the REST API is nothing but a simple API. So if you want, this is the front end. If you are requesting for the back end, this request is known as API. So nowadays, or the general situations, the general requests are known as the REST APIs. So REST is full form is representational. Sorry, API full form is like R is nothing but representational, S is nothing but state, T is nothing but transfer. So representational state transfer, the REST is full form. The full form of REST is, and the API full form is applicational programming interface. And you can see the example over here, and you can see API versioning in the backend. And you need to know about the GraphQL, which is introduced by the Facebook. And the rest is, let's say you only want two endpoints, which is let's say you want a username and let's say it's username and let's say user ID. You want these two fields, but what this REST will do is it will be going to fetch all the details. Let's say how many number of orders we have, what are the orders we have cancelled, all the details it will be going to return, so that the REST application is very so that the Facebook found this opportunity to build an API. So they built this API called GraphQL. So whatever that you want, let's say I have username and user ID, I only want these two fields. So the GraphQL can do this thing. So you can see single endpoint, client asks for the exact field name needed, client asks for exact field needed. Avoid overfetching and underfetching, good for mobile apps with limited bandwidth. Okay, whatever the limited bandwidth, in that bandwidth only you need to send all the data. So at that time you need to use this GraphQL. So another thing is from the Google, that is known as gRPC, which is binary protocol buffer, faster than REST/JSON. Okay, used for internal service communication, support streaming, all the stuff you can see. This WebRTC is used to stream the data, that kind of stuff. Okay, so if you want to understand the timeline, so the first API was introduced, that is known as Cobra, released in 1991, and after that within the 2 years we have something known as RDA. So after that we have XML RPC, and the first important thing that is known as SOAP, that is released in 1999, and REST API was introduced. REST API is very important, right? That was introduced in the 2000s. So after the REST we have JSON RPC, we have Kodak, we have GraphQL introduced in the 2015 from the Facebook. Okay, gRPC we got from the Facebook, sorry, Google. So like this, within year by year, the representation of the data or the transfer of the data has been very significant with the help of these APIs. So what are the types of APIs we have? We have public APIs, private APIs, partner APIs, we have composite APIs. And the types of, we need to test the APIs to have the good proper system design. We need to take care of all these APIs and all the stuff. Okay, the transferring of the data, how user requests, and how we need to send the data. In the data, what fields we need to have, all this stuff. After building, you need to test them. So we have unit testing, integration, performance, load, runtime detection, security testing, and validation testing. All these testings are done by the testers, like software testers. So this is a separate field, software testers. So this is a separate role. So this within this role, the performer, the tester, will test this with the help of code. So the next important section that we need to understand is about authentication and authorization. For a good system, let's say you are going to use a e-commerce platform, so you are in the cart. So without logging in, you cannot able to order the items. So that is the one of the main important thing that you need to take into consideration. So authentication is very important for any of the big platforms. So for authentication, we need to understand what is JWT, what is OAuth. So in the Spring Boot, we have Spring Boot, and we need to know about JWT and all this stuff. Okay. So what is session based authentication, and JWT, which is stateless. Okay, what is stateless authentication, stateful authentication, token based authentication, through, and all this stuff you need to understand. Okay, you can read all this stuff here. And the next thing that we need to understand for a good system design, that is about consistency and availability. I hope we have already talked about Cape theorem. So the Cape theorem is the same thing here, the consistency availability patterns we have. Okay, the strong consistency, eventual consistency, causal consistency, you can see the definitions over here. And availability, we have something known as failure, replication, health check plus auto restart. And the next important section we have as rate limiting. So I have discussed in this sessions only many times about rate limiting. So this is the user, so this is the backend, or this is the front end. So how many number of requests per minute or per month or per second, that is our wish, that let's say 10 requests per second. So this is the rate limiting that we put. Then user can able to send only 10 requests per second. He cannot send more requests, and he can send less requests, that's no problem, but he cannot send more than 10 requests per second. So this is one of the main users for the backend. It cannot handle the more request, means it is one of the best for this backend. Okay, so rate limiting is very important. And to stop spamming also, we put the rate limiting. Okay, spamming is nothing but sometimes scammers will send hundreds, thousands of requests per second. So that time that the load will not be handled by all backend. So for that reason, we need to make sure that rate limiting is there. It is possibly a good thing. And in the rate limiting, we took about the algorithms about token bucket, leaky bucket, and fixed window counter and sliding window log. Okay, all this stuff that we need to take into consideration. And again, as I said, the simple code snippets, the Redis, token bucket, and simplified thing. So for this rate limiting also, I have put small code snippets for you. So rate limiting, I am writing here rate limiting. So for this rate limiting, you can see the code snippets in the Node.js. So first of all, we can say the allowed part. So allowed part, we are having this this function. So we are saying key, we are getting that key from the user ID. We are getting the count, that always we are incrementing with the help of that key. So we are checking that count is equals to 1 or not, if that is the correct that, and we are checking that Redis client dot expire dot 60 seconds. Okay, and you can return the count less than is equal to 100 or not, and 100 requests per minute. So this is the rate limiting that we are putting on this function called allowed, that 100 requests are allowed only for minute. In the Spring Boot, we can have like bucket is equals to, this is a class, right, and we are making an object here, bucket 4j dot builder. There is a function called dot builder, so we can call the dot add limit dot build. So you can set 100 seconds and duration of 1 minute. You can see you can allow all requests. If bucket dot try consume, you can consume in this fashion. And the next important section in the system design course is containerization. So I want to explain you in detail about this containerization, how you can make containers and all the stuff. So I have a dedicated video on the Docker containerization. You can please watch that video so that you can understand the basics of this Docker. So this is not the detailed video about Docker. I just want to explain you the system design. So in the system design, this Docker also, this containerization also is part. So that's why I'm explaining the Docker here. So why Docker only? Because I will explain how this actually performs. So actually I came here. So how Docker works, if I explain that, then you can understand. So first of all, this is your operating system. On this, actually some part of there, this is the actual hardware. So on the top of the hardware, we have something known as, this is the Docker engine, like Docker daemon. So Docker daemon is nothing but the actual thing that will be going to run the main engine, Docker engine. So on the top of this, we have separate service. Let's say this is service 1. On next we have service 2, service 3. So in this fashion, all the services that we can run, how many services we want, we can run. So this will not be connected with this. This will not be connected with this. This will not be connected with this. If you want, you can make connect with this. Okay, if you want, you can connect. This is the actual what Docker will do is, let's say this is the whole application. So inside this application, we have Node.js, we have Express, and we have, let's say, some other stuff all over here. Now you put all this in a like, let's say let's say not container, you put all this in an image. Okay, this image is like a class. Okay, this class is of nothing use. This image is of a class, so this class is of nothing use, and let's say class name is node. So this class is of no use, this image is of no use until unless you make a container. Okay, until unless you make a container, because this container is the one that will run this image. The container is the one that will run this image. Okay, the node is of no use, the class is of no use until unless you made a node n1. It's an image, it's an object. It's an object. Until unless you made an object, this class is of no use. Is this class of no use, so that you made objects to use this class. So that's why the image is also a simple thing, that you cannot use this image directly. If you want to run this image, you need a container. So in the image, you can contain all this particular thing. Okay, so now first of all, you can get it out. So what is the main use of this Docker and all the stuff? What is the image? Let's say in the previous days, so I am using Node.js version, let's say 18, and I am using Express version of some, let's say 2. So I am using some of the other versions of the other thing. So my colleague is using Node.js something version like 16, and Express something version as something like 6. So there is no compatibility issue, but both the workers are, like, both the employees are working in the same company. So here is the conflict. When both of them will deploy to the single GitHub, so some of the compatibility of issues will be coming with the help of this and this. So that's the reason what we are going to do is, we are going to make a image, and we are going to send this image to the Docker hub. So this is known as Docker hub. So as this is known as Docker hub, in the Amazon AWS, we something known as registry. Registry. I have already showed you the registry. So after getting into the Docker hub, what the user, this is user 1. User 1 can pull this image from here. User 2 can pull it from here. User 3 can pull here. So if there, let's say I have image. Let's say I am user 1. I have image of my colleague that he had made. So I can deploy this image. I can deploy. Let's say this is the image. I can deploy this image. So in the image, you can run the services. Okay, this is deployed. This will run 24/7. So 24/7 with the help of this image, I can run the container, so that this service images will be running 24/7 in the container, in that particular Ubuntu service in the hosting. So in the hosting, I took a Ubuntu mission. I dragged from the Docker hub that image. I am running it with the help of a container 24/7. That image will run, so that only one image will be running 24/7. So as that one image is running 24/7, any user can go and make a request to that to the Docker, like to that image or the container. He will get the response. So in that way, Docker works. So you can see, I have written down the image and versus container topic for you. So image is like a blueprint ready to use layers. Container is a running instance of that image. So if I come down a little bit, I already explained on the top of the Docker daemon, so many apps running for us. You can make how many apps you want. So but if you see the normal operating system, so this is a virtual machine, like it's a Windows, let's say it's a Windows, it's a Ubuntu, it's a Kali. So it's a Kali Linux, it's a Ubuntu, like so many distributions will be there. Virtual machine 1, we have separate guest OS, operating system, in this fashion. But the Docker also having the similar kind of stuff, but it's a separate thing. Okay, Docker is similar kind of thing, but it's a separate thing. And the complete architecture of Docker, if you see clearly over here, you can see first of all Docker client will be going to ask for the Docker daemon. So Docker daemon will be asking for the Docker engine and Docker container. So Docker engine going to container. And first of all, we are going to push to the we need to create the Docker image, and we need to push to the Docker registry, which is the Docker hub. So after that, we can run that image from that Docker registry. We can see all the running instances. So we can directly check that in the Docker engine also as well. So you can see we can access all the REST APIs in the Docker client. Okay, that's the architecture of the Docker. So if you know about the Docker daemon, you can see. So Docker daemon is the main service engine which runs all the services. So with the help of this Docker daemon, we can make all the API requests also. So for that, we need to have the port binding. So with the help of this port binding, we can have the stuff. Okay. So how we can do that? How we can do that is very important and easy also as well. You can, if you follow any Docker video, you can get to know that. So after that, we can see we can have Docker networks, Docker containers, Docker image, Docker volumes. We need to manage our Docker volumes by ourselves. Okay. So Docker image lifecycle you can see over here. Docker container has some lifecycle. Docker network and storage over here, and Docker container orchestration. So this container orchestration is managed with the help of K8s. So this K8 is nothing but Kubernetes. Okay. So don't worry, we will going to talk about the Kubernetes in a detail. So this is how you will write in the Docker file. So in the Spring Boot or Node.js, you will write in this fashion. In the Spring Boot, you will write in this fashion the Docker image. So if you come down, so you can see how you can write Docker compose.yaml also. So this is also very important. So the next important section that we need to discuss here about is K8s. So K8s, for that you need to come here. So first of all, what is meant by K8? So if you write KS, if you remove this in between, we have total 8 letters. So that's why the representation of Kubernetes is K8s. So first of all, this Kubernetes was built by Google. So this is the container orchestration tool. So this Google, what it did after it has built by itself, then they made this Kubernetes as the open source. Now anyone can build with the help of this Kubernetes with a ease manner. So you can, if you see the logo also, the Kubernetes is coming from a Latin word which is like a sailor riding a boat, right? So I will be going to explain what is meant by this, how you can run this Kubernetes in an easy manner. Let's say you have a EC2 instance. In that you have Ubuntu installed. In this Ubuntu you are running one Docker image. Okay, one Docker image. Another, let's say you have another EC2 instance, another Ubuntu installed. In that you have another Docker image, and similarly you have up to 50 like EC2 instance 1, EC2 instance 2, up to EC2 instance 50. You have instance Ubuntu, and you have Docker installed inside that, and we have image 50 over here. Now imagine, so you need to go SSH into that mission. You need to SSH into that mission. You need to start this mission. You need to SSH, and after that you need to run this Docker image. Same way you need to run this Docker image. You need to SSH into that mission, 50th mission, and you need to run this Docker image. This is a huge TDE process. Okay, so for this TDS process, there is something known as K8s. So what this will do is, basically this will completely change this architecture. So in the K8s, we have something known as control panel. So what is this control panel? So control panel is nothing but the main mastermind. Let's say this is as mastermind, and this control panel will be having some as a node. Okay, we can have so many nodes. It can control so many nodes. Okay, let's say in between we have so many nodes. So inside a node we have something known as pod. Okay, inside a pod we have something known as container. This is container 1. Let's say container 1, container 2. Here also we have something known as pod. Okay, this is container 1, this is container 2. So in this fashion we have node, let's say node as a building, and if you understand with the analogy of the building, you can get to know very simply. And pod, like container is a people, containers are the people, pod is a apartment, and pod containers are the people. You can multiple people can stay in a single apartment. In the similar way, in a single pod we can store multiple containers, but generally what we do is, in a single pod we will going to store a single container. It's a general thing, but you can store how many containers you want. Okay, that's not a thing. So in the single node, let's say in a building, you can have multiple compartments. In the similar way, in a single node we have multiple pods. Okay, here also we can have multiple containers. In the similar way we can have so many pods. In the similar way we can have so many nodes. In the similar way we can have so many pods. Okay, so what control panel will do is, we can have some data storage layer, and we can have some controlling layer for controlling all these nodes. Now for this issue, for this issue. So we have one issue, right? We have 50 services, and how we need to manage, how we can start all the images at a time, how we can end all the images at a time, how we can monitor all the images at a time, this thing stuff, right? So this thing can be managed with the help of Kubernetes, right? So I basically explored the control panel and node in the Kubernetes. Basic stuff of Kubernetes I explained now. So now how can we manage all these 50 containers, 50 services, 50 servers, that kind of stuff. So what we can do is, this is the main instance. These are the main, let's say we have total 50 servers. Let's say this is EC1, like EC2 1, EC2 instance 2, EC2 instance 3, up to EC2 instance 50. Okay, EC2 instance 49, EC2 instance 48. Now my question, not question, let's say a control panel. So what we can do is, we can keep total, let's say our wish, that is our wish. So let's say I want to keep these three control panels. Let's say EC2 1, EC2, EC2 3. These three servers will be acting as my control panel, and remaining all these 47 remaining 47 will act as my like master nodes or slave nodes. Let's say slave servers, or I can say like that, slave server, something like that I can say. So what these all remaining things will do, this will be basically containing all the nodes, all the node servers will be containing in this, all the like master will be containing, all the control panel services will be there. So these three servers will be controlling all these services. So if you want to start all the services, you go here and say that I want to start all the services. If you go here, which is controlling, let's say it is controlling 10, let's say 15 it is controlling. If you go here and you can say that I want to stop all the 15 services. So done, all the 15 services. So here also if you say all the 15 services is done, so it also all the 15 will be done in a similar way like this. So from this, what you understood? So from this, what we can understand is, instead of going all to this 50 services, you can go only to the 3 services. You can just go to these 3 services and you can just start all these 3 services, or you can stop all these 3 services, then complete all these 47 services will be stopped. So that's how this Kubernetes works. So if I again come back, you can see, so it's saying that why Kubernetes. So Kubernetes is a container orchestration tool. So Docker runs only one container, where the Kubernetes manages hundreds across many machines. So we can run hundreds of containers at a single time. So you can see all the benefits of the Kubernetes, why we are using that, and so many stuff we have, okay, to maintain multiple services that we have already understood. So as I already explained you, so we have something known as control panel. Inside that we have some 3 layers. So scheduler, control manager, API server. So we have something known as node, multiple nodes we have. So multiple nodes can contain multiple number of pods. Each pod can contain one container. So we have already understood. So you can see containers are people, pods are apartments, nodes are buildings, clusters are entire society. This control panel is right here. That is known as society office. Okay. A node is simply a machine. It can be a physical server, virtual machine, EC2 instance, or an Azure VM. We are saying node, right? So this node. Okay, this node is a server, physical server that I'm saying, right? This control panel is also a separate physical server. So if you come down, you can see that we have Kubernetes, API services, cloud manager, and also many stuff over here. And here also it's talking about master and worker nodes, okay, or slave nodes we can call it as. So master, this worker node, and all the stuff. So we have something known as EDTC. As I said, mentioned in the worker node, we need to store data. In the etcd, we need to store the data. It will store the data. This will manage all the resources and it will schedule all the things. So in this way, you can manage the master node. So this kubelet, kubeproxy, and all this stuff will be managed by this worker node. So these two are required to run the worker node. So if you want to run the worker node, you need to run this kubelet and kubeproxy. So the same example that I have explained in that board, so the same example written over here. So if you have total 50 servers, so let's say these 3 servers I'll make it as a like a control panel, and remaining things I will make is a worker nodes. And each node will be having these things, that is API service, scheduler, control manager, etc. And you can read the stuff what I have written over here. You can understand the stuff. So you can see the first application, build a Docker image, push to the Docker hub. So you can write Kubernetes YAML file. So after that, kubectl you need to apply. Then the API service receive the request. Then scheduler manages that. Then kubelet pulls the Docker image. Then container runs that pod. then application exposes, then finally user access that application. So basic I have explained what is Kubernetes. So you can see all the Kubernetes stack wheel. So monitoring tools, infrastructure organization, networking tools, cluster management, security, container runtime. So out of all this, something known as, there is something known as traffic. So please make sure you check out this, what is meant by traffic. You can Google it, you can understood that. So there are so many open source tools also included here. So if you come down, there are 17th one. So section 17 section, this is the last section, not last section, last but what section. So the next important thing that we need to understand is the CI/CD pipelines that we need to understand in the complete system design. So system design is to design a well-versed systems, right? So for that purpose, we need to understand the system design, or like CI/CD pipelines also. So CI/CD, for the full form is CI, continuous integration, CD, continuous delivery. So we need to continuously continuously integrate it and continuously deliver the product. So that's known as the stuff. Okay. So there are so many kind of deployments that we don't know, but we need to know when you are in a company or in a stuff. So deployment strategies we need to follow. We have the blue-green deployment, we have canary deployment, we have rolling deployment. Right now you don't want to know about that. So just know about that. We have in the CI/CD pipelines, we have so many deployment strategies. In that, blue-green also is one of the part. And this is the one of the code that Node.js, Docker, and K8s. The GitHub actions you can write in this GitHub, like CI/CD pipeline you can write in this fashion. So majority of the time for the CI/CD pipelines, you are going to use the Jenkins. So if you want to plan, code, build, test, release, deploy, operate, and monitor your code bases after pushing to the GitHub, then you can use this Jenkins tool. It's one of the very important tool to run the CI/CD pipelines. So you can also understanding the what is this continuous testing. So the CI means continuous integration, CD means continuous deployment. You can see it's like a pipeline, it has been represented to you. So first of all, like source stage, build stage, team stage, deploy, business test, like deploy for the production state, production ready, and finally if you after continuously integrating that, another feature came, you need to integrate all the stuff. Now another feature came, or new previous feature has been removed, then also you need to process all these steps, and you need to come back in this fashion. You can also see commit change to deploy production. This is known as CI/CD pipelines. Again, if you come back, you can see this 8 kind of stuff. So for the coding, we can use GitLab, GitHub. So many developers use and know GitHub, like Jira for the ticketing, and Docker, Amazon Lambda. I explained that, Kubernetes, Terraform, and Datadog for the data. We have used Jenkins, JUnit for the testing. So just and Webpack, okay, Gradle. So these are all the deployment, test, and monitoring tools that we need to use for the CI/CD pipelines. So if you come down, so this is the last section that we need to understand in the complete thing of this system design. So this is the advanced patterns. So in the advanced patterns, we use something known as command query repository segregation, event sourcing, and if you come a little bit down, we have Saga pattern, we have circuit breakers, and come down a bit, item potency. We need to ensure that distributed logs, consensus algorithms. And finally, I want to discuss you with that classical system design case studies. Okay, we have something known as URL shortener, chat app, notification system design, e-commerce ordering system design, rate limit services, and news feed. All these services that a single like system design we need to design, so that we can understand system design completely by ourselves.